गुड इवनिंग, नमस्कार। कैसे हैं आप सभी लोग? उम्मीद है कि आपका एग्जाम बहुत अच्छा हुआ होगा और नहीं भी अच्छा हुआ है तो कूल डाउन, अभी पता चलेगा कि अच्छा हुआ या बुरा हुआ, वो सब बाद में देखेंगे। जो हो गया अच्छा ही हुआ होगा। आई एम सुनील कुमार तिवारी एंड आई वेलकम यू ऑन बिहाफ ऑफ मेड इजी टीम. आई एम हियर टू discuss the solutions of today's examination of engineering services prelims इलेक्ट्रॉनिक्स इंजीनियरिंग पेपर 2, राइट। अगर मुझसे पेपर के लेवल की बात की जाए तो मैं ये कहूंगा कि मॉडरेट पेपर है, ना ही बहुत इजी है और ना ही बहुत डिफिकल्ट। ये मैं अपनी सब्जेक्ट की बात नहीं कर रहा हूं, ओवरऑल पेपर का अपने कलीग्स के साथ, अपने फ्रेंड्स जो मेडीजी फैकल्टी टीम है उनके साथ डिस्कशन के बेसिस पर जो हमारा कंक्लूजन है वो ये है कि जो ईसी का पेपर है, जैसा इंजीनियरिंग सर्विसेज का पेपर आता है मोर और लेस वैसा ही है। अब क्योंकि आप एग्जाम देते हैं तो आपकी तैयारी थोड़ा खराब है तो आपको लग रहा होगा बहुत डिफिकल्ट है, अगर थोड़ी तैयारी अच्छी है तो लग रहा होगा बहुत ईजी है। लेकिन एज एन एक्सपर्ट जो मेरा ओपिनियन है वो ये है कि मॉडरेट है, ना ही बहुत इजी है और ना ही बहुत डिफिकल्ट है। ये मैं इसलिए बोल रहा हूं कि अगर आप कट ऑफ के लिए जजमेंट करना चाहते हैं तो मोर और लेस नियर अबाउट जो लास्ट ईयर की कट ऑफ्स रही हैं उसके आसपास ही रहना चाहिए। 10 to 15 मार्क्स अप एंड डाउन होने के चांस नहीं है, लेकिन नियर अबाउट 10 to 15 मार्क्स अप हो सकती है या उसके आसपास ही रह सकती है। सो जिनका एग्जाम अच्छा हुआ है या क्लोजर टू द कट ऑफ है, 5 मार्क्स लेस या 5 मार्क्स मोर, यू आर विद इन 5 to 10 मार्क्स लेस और मोर, देन यू शुड स्टार्ट प्रिपेयरिंग फॉर द mains examination. If you want to take the support of MADE EASY, you can take the support of MADE EASY Mains classes, and there we will be giving you some structured content for the mains examination. And if you are far away from the cutoff, then don't be so optimistic कि आप अच्छा कर ले जाएंगे। यदि आप 40-50 मार्क्स डाउन है फ्रॉम द लास्ट ईयर से कट ऑफ तो फिर डिफिकल्ट है, क्योंकि कट ऑफ डाउन होने का कुछ खास मुझे नहीं लग रहा। हाँ, 5 to 10 मार्क्स इज ऑलवेज, दैट इज ब्यूटी ऑफ द एग्जामिनेशन, नॉट प्रेडिक्टेबल, क्योंकि कई बार जीएस में कुछ अप एंड डाउन हो जाता है, कई बार टेक्निकल में भी कुछ क्वेश्चंस अप एंड डाउन हो गए, तो 5 to 10 मार्क्स प्लस माइनस कैन बी देयर, बट नॉट अ मेजर डिफरेंस नहीं हो सकता। किसी ने लिखा है कि पेपर लेंदी है, ऐसा ही पेपर आता है इंजीनियरिंग सर्विसेज का, लेंदी ही आता है। इंजीनियरिंग सर्विसेज में गेट की तरह बहुत डेप्थ क्वेश्चन नहीं आते हैं, मोर और लेस थ्योरेटिकल या थोड़ा कैलकुलेटिव, थोड़ा लेंदी, ऐसा ही पेपर आता है। वहां आपको टाइम मैनेजमेंट करना होता है। सो मेरे हिसाब से पेपर जैसा होना चाहिए वैसा ही है। मैं अपनी दोनों सब्जेक्ट का डिस्कशन आपके साथ करूंगा। हम ईडीसी से स्टार्ट करेंगे, फिर ईडीसी और मटेरियल साइंस के क्वेश्चन डिस्कस करेंगे, उसके बाद मेरे अदर कलीग्स आपके साथ है डिफरेंट सब्जेक्ट्स का डिस्कशन करेंगे। चलिए ईडीसी के क्वेश्चंस की बात करते हैं। पहला क्वेश्चन है, कंसीडर द फॉलोइंग स्टेटमेंट्स रिगार्डिंग ट्रांजिस्टर फेट्स आर लेस टेंपरेचर स्टेबल कंपेयर टू बीजेटीज। नहीं, मैंने आपको साफ साफ बताया हुआ। इनफैक्ट आप जाएंगे अगर अनुनाद ग्रुप पर, अभी भी एक पिंड मैसेजेस में एक एफईटी और बीजेटी का कंपैरिजन लिखा होगा और उसमें यही लिखाया होगा कि एफईटीज आर मोर थर्मली स्टेबल देन द बीजेटी। तो ये स्टेटमेंट तो सही नहीं है। सो अगर हम फर्स्ट स्टेटमेंट की बात करें तो ये गलत है। देन FET is a current controlled device whereas BJT is a voltage controlled device. Wrong. FET is a voltage controlled device whereas BJT is a current controlled device. Right? So ये भी गलत है। ठीक, FET has zero offset voltage at zero drain current and hence it makes an excellent signal chopper. जी हाँ, ये सही है। Actually ये as it is statement शायद उस कंपैरिजन में जहां मैंने लिखा है एडवांटेज डिसएडवांटेज, वहां पर एक पॉइंट लिखा हुआ होगा। और चॉपर हम लोग बेसिकली डीसी टू डीसी कन्वर्टर्स होते हैं, पढ़ते नहीं है, बट ये पॉइंट आईएएस में कई बार प्रीवियस ईयर में भी पूछा गया, तो अगर किसी ने पीवाईक्यू किया होगा तो भी इसको कर लेगा। तो थर्ड स्टेटमेंट इज करेक्ट, फर्स्ट एंड सेकंड इज रॉन्ग। लेकिन ध्यान दें, आपसे पूछा है व्हिच ऑफ द फॉलोइंग आर नॉट करेक्ट। सो आपका आंसर क्या होगा? 1 and 2, यानी ऑप्शन ए, बिकॉज यू हैव टू चूज द नॉट करेक्ट ऑप्शंस। सो क्वेश्चन 6 का आंसर हो जाएगा ए। कोई लगातार लिख रहा है कि 2025 में भी दिया था, दिस टाइम वाज टफर। नहीं, ऐसा आपको लग रहा है, ठीक है। आप अपना ओपिनियन मुझ पे मत लगाइए। इट वाज मोर और लेस एज इट वाज इन 2025, जैसा पिछले साल था लगभग वैसा ही है। थोड़ा शांत मन से, अभी तुरंत एग्जाम दे करके आए हैं तो ऐसा आपको लग रहा है, थोड़ा शांत मन से देखेंगे तो आप भी मुझसे एग्री करेंगे। विश्वास करिए, पिछले 15-16 साल से हम यही कर रहे हैं, तो बिलीव मी, ठीक है। कंसीडर द फॉलोइंग स्टेटमेंट्स रिगार्डिंग फील्ड इफेक्ट ट्रांजिस्टर, मॉसफेट्स प्रोवाइड्स वेरी लो इनपुट इंपीडेंस कंपेयर टू जेफेट। गलत। MOSFETs has very high input impedance as compared to JFET as comparison to BJT। क्यों? क्योंकि MOSFET में एक इंसुलेटिंग लेयर होती है और ऑक्साइड की लेयर, इसका नाम ही क्या है, MOSFET, मेटल ऑक्साइड सेमीकंडक्टर। सो मेटल और सेमीकंडक्टर के बीच में जो ऑक्साइड की लेयर है, इट प्रोवाइड्स वेरी हाई इनपुट इंपीडेंस। सो स्टेटमेंट 1 रॉन्ग है। अब देखो, इस तरह के क्वेश्चन करने के लिए सारे स्टेटमेंट देखने की जरूरत नहीं है। व्हिच ऑफ द अबव स्टेटमेंट्स आर करेक्ट, आपसे करेक्ट पूछा है, 1 रॉन्ग है। 1 रॉन्ग है तो 3 ऑप्शन कट गए, 3 ऑप्शन कट गए तो ऑप्शन सी सही हो जाएगा। सो फॉर दिस क्वेश्चन द आंसर इज ऑप्शन सी। आप देख भी लीजिए, डिप्लीशन टाइप मॉसफेट कैन बी यूज्ड बोथ बीजीएस पॉजिटिव एंड नेगेटिव एनहांसमेंट एंड डिप्लीशन मोड रेस्पेक्टिवली। FET शुड बी बायस्ड इन द सैचुरेशन रीजन इन ऑर्डर टू बी यूज्ड एंड एम्पलीफायर। ये दोनों स्टेटमेंट सही हैं, मुझे कोई दिलचस्पी नहीं है। मेरा आंसर सिर्फ इसी बात से आ जाएगा कि मॉसफेट प्रोवाइड्स वेरी हाई रेजिस्टेंस एज कंपैरिजन टू द JFET। नेक्स्ट चलते हैं, नेक्स्ट क्वेश्चन। Consider the following statements regarding semiconductors. At room temperature, there are approximately 1.5 into 10 to the power 10 pre-carriers in cubic per centimeter of the intrinsic silicon। जी हाँ मित्रों, अगर आप देखें तो जब मैं Ni की वैल्यू क्लास में आपको पढ़ाता हूं तो सिलिकॉन, जर्मेनियम और गैलियम आर्सेनाइड तीनों के लिए 300 केल्विन पर पढ़ाता हूं। किसी ने पर्टिकुलरली एक सब्जेक्ट के लिए लिखा है कि सर कम्युनिकेशन, पेपर, कंप्यूटर, ऑर्गेनाइजेशन, आर्किटेक्चर सब बहुत टफ था, मोस्ट सब्जेक्ट्स आर टफ। आप मानो या नहीं बेटा, 1-2 सब्जेक्ट हमेशा, पिछले साल कोई दूसरा टफ रहा होगा, इस साल कोई दूसरा टफ आया हुआ है, हम ओवरऑल पेपर की बात कर रहे हैं, आप मेरी मानो, ठीक है, चलिए कोई बात नहीं। जब हम NI पढ़ रहे थे, अच्छा आप मेरी तब मान लेना जब रिजल्ट आएगा और कट ऑफ अगर बहुत डाउन हुई तो मैं आपकी बात मान लूंगा, आपसे सॉरी बोल दूंगा, और अगर कट ऑफ मोर और लेस सेम रही तो मैं सही हूं और सेम रहेगी। 5-10 मार्क्स अप एंड डाउन, दैट इज पॉसिबल। ठीक, NI मैंने सिलिकॉन के लिए आपको पढ़ाया हुआ है 1.5 into 10 to the power 10 पर सेंटीमीटर क्यूब। ये सारा हम रूम टेम्परेचर पर बात कर रहे हैं। इफ यू रिकॉल, दिस इज एट रूम टेम्परेचर पर सेंटीमीटर क्यूब। ये पता नहीं क्यों चल ही नहीं रहा इसमें, हाँ चलो सब सेंटीमीटर क्यूब में ही है, इतना आप जान रहे हो, छोड़ दे रहा हूं मैं। एंड NI फॉर द जर्मेनियम, किसी को याद हो तो ये भी मैंने लिखाया है। NI फॉर द जर्मेनियम कितना लिखा है, 2.4 into 10 to the power 13, 10 to the power 13 पर सेंटीमीटर क्यूब। अब इन दोनों का रेशियो अगर निकालते हैं आप, इस स्टेटमेंट में देखो, फोर्थ में क्या कर रहा है, द रेशियो ऑफ नंबर ऑफ कैरियर्स इन जर्मेनियम टू दैट ऑफ सिलिकॉन इज। सो अगर आप जर्मेनियम और सिलिकॉन का रेशियो निकाल रहे हैं, सो इट इज 2.4 into 10 to the power 13 divided by 1.5 into 10 to the power 10 and this is equal to ये कितना हो जाएगा, approximately 10 to the power 3। बट इस स्टेटमेंट में क्या कह रहा है, 10 to the power 5। सो दिस इज रॉन्ग। ठीक, थर्ड रॉन्ग है और आपसे पूछा है करेक्ट स्टेटमेंट कौन सा है, तो थर्ड 3 ऑप्शन में है, इनको हटा दीजिए, यानी ऑप्शन ए सही हो जाएगा। अब अगर आपने ये सब टेक्निक्स लगाई होंगी तो पेपर इजी लगेगा। अगर आपने एक एक स्टेटमेंट वेरीफाई किया होगा तो इसका मतलब आपने सिंसियरली इंजीनियरिंग सर्विसेज की तैयारी नहीं की है, फिर आपको डिफिकल्ट लगेगा। तो ट्राई टू, मैं इन सब एस्पेक्ट को भी ध्यान में रखता हूं जब पेपर कह रहा हूं कि इजी है, डिफिकल्ट है, क्योंकि मुझे बहुत सारे क्वेश्चन ऐसे दिखे जो कि 4 स्टेटमेंट में से 2 बहुत डिफिकल्ट हैं, आप नहीं जानते होंगे, लेकिन आंसर निकालने के लिए उनकी जरूरत ही नहीं लग रही है। एक गलत स्टेटमेंट है, उससे 3 ऑप्शन हट जा रहे हैं और आंसर मिल जा रहा है। अभी कई सारी जगहों पर ये चीज देखेंगे। ठीक है, नेक्स्ट आते हैं। कंसीडर द फॉलोइंग स्टेटमेंट्स रिगार्डिंग मॉसफेट बीमॉस। ये क्वेश्चन मैंने बीमॉस मैंने क्लास में नहीं पढ़ाया है, हालांकि बीमॉस PYQ में आया हुआ है, और ये क्वेश्चन अगर कोई सिर्फ क्लास नोट से पढ़ के गया होगा तो नहीं कर पाएगा। एक आध क्वेश्चन हमेशा ऐसे आते हैं जो नहीं हो सकते हैं। बीमॉस मैं इतना बताना चाहता हूं कि पावर मॉसफेट होते हैं, और जो पावर मॉसफेट होते हैं इनका पॉजिटिव टेम्परेचर कोफिशिएंट ऑफ रेजिस्टेंस होता है। अगर इतनी जानकारी किसी के पास होगी तो इस क्वेश्चन को कर लेगा, अदरवाइज नहीं कर पाएगा, छोड़ दिया होगा। सो आइए जरा यहां भी क्या पूछा है, करेक्ट स्टेटमेंट। गलत ढूंढने की कोशिश करते हैं। गलत क्या है, बी मॉसफेट्स हैव नेगेटिव टेम्परेचर कोफिशिएंट। नहीं, बी मॉस पावर मॉसफेट्स हैं और पावर मॉसफेट्स का पॉजिटिव टेम्परेचर कोफिशिएंट ऑफ रेजिस्टेंस होता है। सो स्टेटमेंट 2 इज रॉन्ग, एंड इफ स्टेटमेंट 2 इज रॉन्ग, दिस ऑप्शन कैन नॉट बी करेक्ट, दिस ऑप्शन कैन नॉट बी करेक्ट, दिस ऑप्शन कैन नॉट बी करेक्ट। सो करेक्ट ऑप्शन कैन बी ऑप्शन बी। सो राइट चॉइस फॉर दिस क्वेश्चन इज ऑप्शन बी। दिस क्वेश्चन वाज डिफिकल्ट, इसलिए डिफिकल्ट कि हमने पढ़ाया नहीं है। यूजुअली बीमास आई डू नॉट टीच इन द क्लास। राइट, नेक्स्ट चलते हैं। कंसीडर द फॉलोइंग स्टेटमेंट्स रिगार्डिंग मॉसफेट्स। फॉर द वैल्यूज ऑफ बीजीएस लेस देन द थ्रेशोल्ड। अब तमाम सारी नौटंकी इसमें की गई है। सबसे पहले पूछो करेक्ट पूछ रहा है या इनकरेक्ट, ठीक है, करेक्ट पूछ रहा है, करेक्ट स्टेटमेंट्स आर। अब करेक्ट स्टेटमेंट में जरा एक चीज देखिए, इफ बीजीएस इज लेस देन बीटी, बीटी इज थ्रेशोल्ड वोल्टेज, सो इफ बीजीएस इज लेस देन बीटी देन द करंट शुड बी जीरो। सो ये इक्वेशन नहीं फॉलो होगी, ये इक्वेशन तो तब फॉलो होगी जब बीजीएस इज ग्रेटर देन बीटी, right, either in linear or in saturation, but for that purpose BGS must be greater than the threshold voltage. If BGS is less than the threshold voltage, मैंने खूब आपको पढ़ाया है कि चैनल ही नहीं फॉर्म होगा, किसी भी तरह की करंट नहीं फ्लो होगी, इसीलिए तो इसे एनहांसमेंट मॉसफेट कह रहे हैं, ठीक है। अगर कुछ नहीं लिखा है तो बाय डिफॉल्ट मॉसफेट का मतलब ये एनहांसमेंट मॉसफेट। सो दिस स्टेटमेंट कैन नॉट बी करेक्ट, एंड इफ 2 इज नॉट करेक्ट, दिस इज रॉन्ग, दिस इज रॉन्ग, दिस इज रॉन्ग, सो आंसर इज ऑप्शन बी, ठीक है। अच्छा, अगर आप सभी लोगों को पेपर डिफिकल्ट लग रहा है तो मेरी बात को एक्सेप्ट करने की जरूरत नहीं है, कट ऑफ बहुत नीचे चली जाएगी, मैं गलत होकर के खुश रहूंगा, ठीक है। आई वांट दैट कि मैं गलत हूं, ठीक है, क्योंकि आपका भला हो जाए अगर मेरे गलत होने से, तो अच्छी बात है। कोई कह रहा है कि बट यू आर नॉट एक्सपर्ट, कोई बात नहीं, कोई बात नहीं, मैं नहीं एक्सपर्ट हूँ, आप मुझसे ज़्यादा एक्सपर्ट हैं, गुड। कौन है, MRL लर्नर, गुड 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 गुड। सो इफ you feel that it's easy, sorry, it's a difficult, then it's a difficult, ठीक। Option B is the right choice। Next आते हैं, so this question is question number 70 we have done। So I think EDC के questions इतने ही थे। EDC कम पूछी गई है, EDC पिछले कुछ साल से इंजीनियरिंग सर्विसेज में कम ही पूछी जा रही। चलते हैं मटेरियल साइंस की तरफ। सो लेट्स गो फॉर द मटेरियल साइंस क्वेश्चंस। हम मटेरियल साइंस के जो क्वेश्चंस आए हुए हैं वो डिस्कस कर लें। मटेरियल साइंस एज यूजुअल थोड़ा सा इलेक्ट्रॉनिक्स में जो आता है अलग ही आता है, मतलब ठीक ठाक ही आता है और कम क्वेश्चन आते हैं, बट इलेक्ट्रिकल में बहुत ज़्यादा आते हैं। तो इलेक्ट्रॉनिक्स में जितने आए हैं ठीक आए हैं। देखते हैं, यहाँ भी देखते हैं। कंसिडर द फॉलोइंग स्टेटमेंट्स रिगार्डिंग मैग्नेटिक प्रॉपर्टीज ऑफ मटेरियल, व्हिच ऑफ द अबव स्टेटमेंट्स आर करेक्ट। इनमें से कौन से सही है देखना, मैं फिर गलत ढूंढने की कोशिश करूंगा। When the magnetic moments are equal, the anti-parallel arrangement results in ferrimagnetism। नहीं, जब अनइक्वल होते हैं तब फेरीमैग्नेटिज्म। मैं ये ऐसा ग्राफ बनाता हूं, अगर आपको याद हो तो जब आपको फेरी पढ़ाता हूं क्लास में, सो आई मेक दिस काइंड ऑफ थिंग्स, आई मेक दिस काइंड ऑफ थिंग्स। ये अनइक्वल होता है तो फेरी होगा, और जब इक्वल होगा तो एंटी फेरो होगा। सो दिस स्टेटमेंट कैन नॉट बी करेक्ट, एंड इफ 2 इज इनकरेक्ट, दिस इज इनकरेक्ट, दिस इज इनकरेक्ट, दिस इज इनकरेक्ट, सो आंसर विल बी गिवन बाय ऑप्शन बी। राइट चॉइस इस क्वेश्चन के लिए क्या हो जाएगी, ऑप्शन बी हो जाएगी, ठीक है। चलिए राइट, नेक्स्ट आगे चलते हैं। इसमें बाकी स्टेटमेंट देखो, आज पढ़ाने का मौका नहीं है, तो आज मैं सब कुछ पढ़ाना नहीं चाहता हूं, जल्दी से क्विकली आंसर बताना चाहता हूं, तो इसीलिए मैं कैसे क्वेश्चन लगाएंगे वो बता करके आगे बढ़ रहा हूं। सो सिंस दिस स्टेटमेंट इज नॉट करेक्ट, अगर ये इक्वल होते और एंटी पैरेलल होते तब आपके पास एंटी फेरोमैग्नेटिज्म होता, बट अगर आपके अनइक्वल हैं और एंटी पैरेलल हैं, देन यू विल गेट फेरीमैग्नेटिज्म, ठीक है। सो स्टेटमेंट 2 इज रॉन्ग। नेक्स्ट चलते हैं। कंसिडर द फॉलोइंग स्टेटमेंट्स रिगार्डिंग फेरोमैग्नेटिक मटेरियल, सॉफ्ट मैग्नेटिक मटेरियल्स हैव लो परमियाबिलिटी। यही ये क्वेश्चन खत्म। आप याद करो, सॉफ्ट मैग्नेटिक मटेरियल्स का मैंने आपको क्या पढ़ाया है, लो हिस्टैरिसीस लूप, ठीक है, शार्प एंड नैरो हिस्टैरिसीस लूप। इफ इट इज शार्प एंड नैरो हिस्टैरिसीस लूप तो स्लोप क्या होगी, हाई होगी। एंड इफ यू रिकॉल, मैंने आपको बताया कि अगर dm अपॉन dh हाई है तो काइम हाई होगा, और अगर काइम हाई होगा तो म्यू r -1 हाई होगा, यानी ससेप्टिबिलिटी हाई होगी, परमियाबिलिटी हाई होगी। और पहले ही स्टेटमेंट में कह रहा है कि सॉफ्ट मैग्नेटिक मटेरियल लो परमियाबिलिटी, सो इट इज रॉन्ग। पूछा क्या है, व्हिच स्टेटमेंट्स आर करेक्ट। सो अगर 1 रॉन्ग है तो 3 ऑप्शन करेक्ट कट गए। मैंने इन सब फैक्टर्स की वजह से ही कहा कि पेपर यूजुअली इतने सारे क्वेश्चंस में ये बात नहीं करते हैं वो कि एक ऑप्शन गलत, एक स्टेटमेंट गलत दे करके पूरा क्वेश्चन बन जाएगा, ठीक है। नहीं, 5-7 क्वेश्चन 4 क्वेश्चन में कर देंगे, लेकिन आप देखो ज्यादातर क्वेश्चन में ये चीज की गई है, दैट्स व्हाई मुझे पेपर मॉडरेट लगा। सो आंसर वुड बी सी, इस क्वेश्चन का आंसर सी हो जाएगा। नेक्स्ट चलते हैं। Consider the following statements regarding superconductivity. Metals and compounds which lose their electrical resistivity at absolute zero temperature are called superconductor. Superconductor की basic definition मैंने आपको ये लिखा है, absolute zero की बजाय मैंने low temperature लिखा है, critical temperature के below. तो अगर critical temperature के below जाएंगे तो even low temperature पर भी they lose their resistivity, and this is the definition for superconductors. It is correct. The superconductor state can be destroyed by the application of external magnetic field. Yes, आप देखें क्लास में मैं तीन चीजें बताता हूं जिससे सुपरकंडक्टिविटी डिस्ट्रॉय हो सकती है. एक एक्सटर्नल मैग्नेटिक फील्ड होता है, दूसरा करंट होता है, और तीसरा टेम्परेचर होता है. ठीक है, तो एक्सटर्नल मैग्नेटिक फील्ड से भी आप इसको डिस्ट्रॉय कर सकते हैं. दैट्स आल्सो करेक्ट. द मटेरियल्स व्हिच बिकम सुपरकंडक्टर्स आर नॉट नेसेसरली गुड कंडक्टर्स व्हेन दे आर नॉर्मल स्टेट. जी हां, ये आपके एक नोट में लिखाता हूं मैं, बढ़िया हाईलाइट करके लिखाता हूं कि यूजुअली जो रूम टेम्परेचर पर अच्छे कंडक्टर हैं जरूरी नहीं है कि वो सुपर कंडक्टिविटी शो करें. इनफैक्ट मैं ये भी जब ग्राफ ही बनाता हूं पहला ग्राफ क्लास में तो आपको यही शो करता हूं कि नॉर्मली जो अच्छे कंडक्टर नहीं है जैसे मरकरी, लेड, ये सब रूम टेम्परेचर पर बहुत अच्छे कंडक्टर नहीं है, लेकिन व्हेन दे गो बिलो द ट्रांजिशन टेम्परेचर दे गिव सुपर कंडक्टिंग फिनोमेना. सो दिस स्टेटमेंट इज आल्सो करेक्ट. सो ये तीनों स्टेटमेंट आपको आपके नोट्स में मिले हैं. सो ऑप्शन डी बहुत ही इजी क्वेश्चन था, सिंपल क्वेश्चन था. All three are correct. Next, at absolute zero, the band gap in a superconductor in terms of Boltzmann constant and critical temperature T, बल्कि T क्या ये TC की बात कर रहा है. ठीक, ये मैंने नहीं पढ़ाया है. So this question you can consider it is a difficult question, क्योंकि जो ना पढ़ाया गया हो वही डिफिकल्ट है. तो एक्चुअली जब BCS थ्योरी की डेप्थ में जाते हैं तो क्रिटिकल टेम्परेचर के टर्म में जो बात आती है, ये बैंड गैप पूछा है, मैं पूरा लिख नहीं रहा हूं. इट कम्स आउट 1.76 K into TC. ठीक, बट इनमें से कोई भी ऑप्शन 1.76 इंटू के इंटू TC है नहीं. ठीक, तो नियरेस्ट ऑप्शन जो हो जाएगा वो आपका हो जाएगा 1.5. तो एक्चुअली जो एक फॉर्मूला हम लिखाते हैं ना बोल्ट्जमैन कांस्टेंट वाला 3/2 K TC, तो अगर ये किसी के दिमाग में रहा होगा, हालांकि ये हम नॉर्मल मेटल के लिए बात करते हैं, लेकिन अगर किसी के दिमाग में रहा होगा तो वहां से कोरिलेट कर सकते हो. This question is relatively difficult because this was not discussed by me. ठीक है, मैं बहुत ऑनेस्ट रहूंगा, मुझे कुछ भी ब्रैगिंग करने की जरूरत नहीं. जो पढ़ाया है वो भी बताएंगे, जो नहीं पढ़ाया है वो भी बताएंगे. ठीक, आगे चलते हैं. कंसीडर द फॉलोइंग स्टेटमेंट्स रिगार्डिंग ceramic material. Refractories are special ceramic materials of construction capable of withstanding high temperature in various industrial process. Refractories शुरुआती बैचेस में तो मटेरियल साइंस में GS में पढ़ाया है, लेकिन जो लास्ट में बैच लिया होगा बिकॉज ऑफ टाइम कंस्ट्रेंट शायद उसमें रिफ्रैक्टरीज स्किप हो गई होगी. तो ये थोड़ा लक बेसिस भी होगा, कुछ लोग पढ़े होंगे कुछ लोग नहीं पढ़े होंगे. इट इज करेक्ट स्टेटमेंट. And this is the first, in fact, first statement is correct. हम ऐसा कह सकते हैं. This is question number 31 है ना. हाँ, question number 31 है and that is correct. रिफ्रैक्टरीज का. चलिए आगे चलते हैं. And second is castable refractories have been used in applications of where abrasion resistance at elevated temperature is required and as a protective barrier against corrosion attacked by hot gases and liquids that are highly detrimental to other. ये भी सही है. यहाँ भी गलत स्टेटमेंट से ही क्वेश्चन बनेगा. एक्चुअली जो म्यूलाइट होता है, ये थोड़ा सा रटने वाला क्वेश्चन है. म्यूलाइट जो होता है इसका फार्मूला अगर मैं लिखूं तो इट इज 3Al2O3 into 2SiO2. ये फिक्स इसका फॉर्मूला होता है. ठीक है, म्यूलाइट का. इसमें एक पॉइंट की वजह से ये क्वेश्चन गलत है. ये कह रहा है कि एनी प्रोपोर्शन में ऐड करके हम बना सकते हैं. नहीं, फिक्स्ड प्रोपोर्शन में ऐड होगा तभी म्यूलाइट बनेगा. यानी एल्मुना के 3 के लिए सिलिकॉन डाइऑक्साइड का 2, समथिंग लाइक दैट यू कैन इमेजिन. सो देयर शुड बी फिक्स्ड प्रोपोर्शन, नॉट द एनी प्रोपोर्शन. सो दिस पार्ट इज रॉन्ग, ये गलत है. और थर्ड अगर गलत है तो अगेन 3 पार्ट चले जाएंगे. ऑप्शन ए हो जाएगा. रिलेटिवली डिफिकल्ट क्वेश्चन इफ यू डोंट नो. मटेरियल साइंस में 1-2 क्वेश्चन ऐसे बकवास आते हैं. कंसीडर द फॉलोइंग स्टेटमेंट्स रिगार्डिंग द फिजिकल प्रॉपर्टीज ऑफ द मटेरियल्स. मटेरियल्स की फिजिकल प्रॉपर्टीज के बारे में कुछ स्टेटमेंट है. थर्मल कंडक्टिविटी ऑफ टैंटलम इज मोर देन टंगस्टन. थर्मल एक्सपेंशन इज मोर इन टिन एज कंपेयर्ड टू लेड. इलेक्ट्रिकल कंडक्टिविटी ऑफ बेरिलियम इज बेटर देन ग्रेफाइट. ठीक है, अब आइए जरा इसमें देखते हैं. इलेक्ट्रिकल कंडक्टिविटी ऑफ बेरिलियम इज बेटर देन ग्रेफाइट. नहीं, ये एक्चुअली ग्रेफाइट का स्ट्रक्चर थ्योरी बुक जो है उसमें दिया हुआ है हेक्सागोनल स्ट्रक्चर होता है और sp2 हाइब्रिडाइज्ड होता है। sp2 हाइब्रिडाइज्ड होने के कारण जो 2D प्लेन है उसमें तो 3 बॉन्ड बने होते हैं, बट 4th इलेक्ट्रॉन 3D प्लेन में फ्री होता है। सो इट हैज गुड नंबर ऑफ फ्री इलेक्ट्रॉन्स एंड इट गिव्स गुड कंडक्टिविटी। सो इट हैज ग्रेफाइट हैज बेटर कंडक्टिविटी देन द बेरिलियम। सो दिस स्टेटमेंट इज रॉन्ग। And if third statement is wrong, again the statement 1 and 2 are correct. इनकी अगर मैं वैल्यूज बताना चाहूँ तो टंगस्टन के लिए ये वैल्यू अप्रॉक्सीमेटली तो मुझे भी ढंग से पूरी नहीं याद होगी, ये 170 के आसपास होती है स्टैंडर्ड यूनिट में, और टेंटलम के लिए ये जो वैल्यू होती है ये लगभग 55-56 के आसपास होती है। ठीक है, इसी तरह से थर्मल एक्सपेंशन की अगर मैं बात करूँ तो थर्मल एक्सपेंशन इसका thermal expansion is more in tin as comparison to lead. So tin मतलब Sn, और tin के लिए ये 22 into 10⁻⁻⁶ पर केल्विन होता है। एंड इसी तरह से अगर लेड के लिए इसकी बात किया जाए तो ये लगभग आ जाएगा, लेड इज वेयर, लेड इज दिस, लेड के लिए 29 into 10⁻⁻⁶ पर केल्विन होता है। वैल्यू रटनी होती है, मटेरियल साइंस में हमेशा इस तरह के सरप्राइज आपको मिलते रहेंगे। ठीक, सो व्हिच ऑफ द अबव स्टेटमेंट्स आर नॉट करेक्ट आपसे पूछा है। इलेक्ट्रिकल कंडक्टिविटी, अच्छा सॉरी मैं उल्टा बता रहा हूं, दिस इज करेक्ट, ग्रेफाइट हैज बेटर कंडक्ट, ओके सॉरी, बेरिलियम इज मेटल, मेटल हैज बेटर कंडक्टिविटी देन द ग्रेफाइट, उल्टा बोल गया मैं। सो दिस स्टेटमेंट इज करेक्ट, आपसे नॉट पूछा हुआ है, तो 1 and 2 जो है, सॉरी फॉर द इनिशियल, बोथ आर कंडक्टर, ग्रेफाइट इज आल्सो कंडक्टर, डायमंड के चारों इलेक्ट्रॉन बॉन्डिंग में होते हैं, सो डायमंड इज नॉट कंडक्टर, sp3 हाइब्रिडाइज्ड होता है, ग्रेफाइट sp2 हाइब्रिडाइज्ड होता है, फ्री इलेक्ट्रॉन होते हैं, ग्रेफाइट इज गुड कंडक्टर। बट अगर हम बेरिलियम से कंपेयर कर रहे हैं तो बेरिलियम इज मेटल, मेटल इज हैविंग ऑलवेज हायर कंडक्टिविटी देन दिस। सो दिस इसने नॉट पूछा हुआ है, सो दिस ऑप्शन इज करेक्ट एंड दीज टू आर इनकरेक्ट, यू कैन सी फ्रॉम हियर। सो ऑप्शन ए विल बी राइट चॉइस। ये रटने वाले क्वेश्चंस हैं, थोड़ा सा मुश्किल लगे हो। नेट मैग्नेटिक मोमेंट पर एटम फॉर द फेरोमैग्नेटिक, जिसने 12th में फिजिक्स अच्छे से की होगी कर लेगा, अदरवाइज कोई चांस नहीं है। क्वेश्चन 6 है, ठीक है। कोई लिखा है कि ओनली फैक्ट्स बेस्ड एग्जाम होगा, ऐसे थोड़ी होता है, दिमाग लगाने का कुछ था ही नहीं। अरे नहीं, ऐसा नहीं है भाई, इतना सिलेबस है, इतने सिलेबस को याद रखना ये भी तो दिमाग लगाना है, बहुत दिमाग लगाना है। ठीक है, तो इसका ऑप्शन है। इंजीनियरिंग सर्विसेज में फैक्ट बेस्ड क्वेश्चन आते हैं, बहुत आते हैं। ठीक है, आगे आइए। कंसिडर द फॉलोइंग स्टेटमेंट्स रिगार्डिंग पॉलीमर्स। ठीक, व्हिच ऑफ द अबव स्टेटमेंट्स आर करेक्ट, इनमें से कौन सा सही है। ठीक है, कौन सा स्टेटमेंट सही है चुनना है, तो गलत स्टेटमेंट हम ढूंढते हैं। गलत स्टेटमेंट, पॉलीमर्स कंटेन नॉन मेटेलिक एलिमेंट शेयरिंग इलेक्ट्रॉन्स टू बिल्ड अप अ स्मॉल मॉलिक्यूल कॉल्ड माइक्रोमॉलिक्यूल। नहीं, आपको जहां पॉलीमर पढ़ाते हैं वहीं क्या लिखते हैं, मैक्रोमॉलिक्यूल। इनफैक्ट मेरी लाइन होती है कि मिलियंस ऑफ एटम्स बॉन्ड टुगेदर टू मेक अ लॉन्ग चेन स्ट्रक्चर या मैक्रोमॉलिक्यूल। सो इट्स नॉट माइक्रो, इट इज मैक्रो। सो 3 इज रॉन्ग, एंड इफ 3 इज रॉन्ग देन ऑप्शन ए इज द राइट चॉइस। सो इसके लिए ऑप्शन ए हो जाएगा। ठीक है, रबर वगैरह पढ़ा है तो ठीक है, नहीं पढ़ा है तो यहीं से आंसर निकल जाएगा, बेसिक डिफिनेशन से ही आंसर निकल जाएगा। सो दिस वाज अबाउट क्वेश्चन नंबर 56। आई थिंक हमने सारे क्वेश्चन कर लिए और तो कोई क्वेश्चन नहीं बचे हुए हैं। हाँ, सो ईडीसी और मटेरियल साइंस के जितने भी क्वेश्चंस थे ऑल वी हैव डिस्कस्ड। अब हमारे अन्य कलीग आपसे बाकी के सब्जेक्ट्स के क्वेश्चंस है डिस्कस करेंगे। मैंने पेपर पर अपना ओपिनियन दे ही दिया है, बाकी जो आपका ओपिनियन हो मुझ तक बताइए आप डिफरेंट प्लेटफॉर्म, डिफरेंट डिजिटल मीडियम के थ्रू। ठीक है, जिनका पेपर अच्छा हुआ है या जो क्लोजर टू द कट ऑफ है, आई विल एडवाइज देम नॉट टू वेस्ट इवन अ सिंगल डे। एक भी दिन बर्बाद करने की जरूरत नहीं है। आज सो जाइए, रिलैक्स करिए और कल से मेंस की तैयारी करना स्टार्ट कर दीजिए। इफ यू वांट टू टेक हेल्प ऑफ मेड इजी फॉर द मेंस क्लासेस, यू कैन कॉन्टैक्ट मेड इजी टीम थ्रू द वेबसाइट और थ्रू द डिफरेंट मीडियम्स, एंड you can take the help of MED EASY classes. And if you want to do self study, then take last 15 years of papers and thoroughly analyze what kind of questions are asked in the mains examination, because mains is totally different than prelims. Prelims में आपको ये shortcuts काम आ रहे हैं, but मेंस में आपको इन डेप्थ नॉलेज की जरूरत होगी। सो प्रिपेयर वेल एंड लास्ट जो नेक्स्ट 3 या 4 मंथ के आसपास का समय है, 3.5 के आसपास का, यूटिलाइज ईच एंड एवरी डे वेरी वेल। तो अगर आपका थोड़ा बाउंड्री पर भी प्रीलिम्स में स्कोर होगा तो आप अगर क्वालिफाई हुए तो मेंस में उसको एवरेज कर सकते हैं, एंड यू कैन कम विद फ्लाइंग कलर, यू कैन बी कॉल्ड फॉर द इंटरव्यू। माय सपोर्ट एंड बेस्ट विशेस इज ऑलवेज with you, and thank you very much for watching us, and my next colleague will be coming to discuss the next subject. Thanks a lot.
Yeah, welcome to the digital electronic solution session. Let us check the questions of the ESE, okay? Yeah. It is a question related to the DAC they gave, and they are asking about a 6-bit DAC has a step size of 50 millivolts, then the full scale output voltage and the percentage resolution they are asking. See here, in the case of DAC always we used to discuss that the percentage resolution, which is actually the resolution itself is nothing but a step size, you know that. And of course related to this is the most important question that you can expect repeatedly. Now let me have the discussion of this one here. For this one we know resolution, which is nothing but the step size, is nothing but the full scale voltage by number of steps, like that. And here in this one they are giving this one resolution and also this one, because n is 6-bit means we had to put here like that, and they are asking about this is how much. So here if you put in that the values of that, we can get 2 power n minus 1 into this one resolution. Yeah, we can have, they are asking the percentage resolution. Okay, so full scale voltage, step size already they mentioned, step size already they give. This is nothing but we can say as resolution. So this is 2 power 6 minus 1 into this is of the 50 millivolts. So 50 millivolts. Yeah, this is nothing but the full scale voltage. So based on this it has to be solved. Okay. And in the same manner percentage resolution is nothing but 1 by 2 power n minus 1 into 100, which is nothing but we can have 1 by 2 power n is nothing but the 6 here minus 1 into 100. Based on that if you solve you may get the answer of the option C like that. Okay, right. Yeah, this is a theoretical question, and this one is directly can be answered, and this is 11th one, and also we are having the theoretical questions here. Most of the questions gave theoretical way, and this is also 14th one and 15th, this is also theoretical question they gave. Okay, yeah, this can have the direct answers, but here this is the question related to the K-map they asked. How to solve this one K-map related, we will check that. Okay, K-map related. But here A, B, C, D, this one 4 variable K-map, that's why we took like that. Here we are going to have this one as A bar, B bar, A bar, B, A, B, A, B bar, C bar, D bar, C bar, D, C, D, C, D bar. Yeah, here first we will identify this A, B bar, C. A, B bar, C is nothing but here A, B bar, and C is here and also here. From this only we got as A, B bar, C. Next one B, B in the sense here, here, here and here also. All this one octet, from that only we got this B. Next B, D bar. So this is B and D bar is here, and this is B, D bar is here, B, D bar and B, D bar here. And next one A, B, D bar. So this is A, B, D bar here and A, B, D bar here. So this is also next A bar, C. So A bar is here and here, C is here and here, A bar, C here and here like that. So this is the way we are having. So this one is one octet from which you can have the B, and this is another octet from which you can have the C. So this is nothing but the B plus C. That will be the option here. Yeah, we can get like that. Okay. So this is the way you can solve that. Questions so simply they gave. Easily came up from there to solve. It is so easy thing, isn't it? That is the way. Right. Another came up question also gave. Yeah, this is a question related to the POS form, as it is expected. Every time I used to say that POS form is very important for the exam, even it is ESE or the gate like that. So in this one, to solve the question, first you make that one as the question in that the K-map itself should be changed. In the K-map, you have to make the two changes, right? Actually, it is a 5 variable K-map, but the K-map in that 2 steps should be made. Number 1, step 1 is nothing but we have to make interchange the operator. Interchange the operator, dot plus should be interchanged. Step 2, in this one we have to make that not only the interchanging the operator and complement the individual variable. Complement the individual variable. So these are the 2 steps should be done in the K-map first. Don't care numbers are going to be as it is, don't care even in the POS also, but the sigma small m numbers should be made as pi capital M, other numbers should be taken, and don't care will be as it is, don't care there also. Based on that, in the 5 variable K-map it should be solved. So the K-map has to be completely changed. Further, these 2 steps should be involved in that. Based on that you should solve that. Okay, check that one please. Right. In this one, remaining theoretical questions can be solved easily in our MADE EASY, directly MADE EASY theory book itself. The answers are there for that, the theoretical questions. And for this 5 variable K map, interchange the operator and complement the individual variable. Based on that, you have to solve this one. And if you solve by applying those two steps in the K map, you can get the answer so easily. Right.
Dear students, we welcome you once again. I am Iftikhar Ahmed and I have with me Rajkumar sir also. We both will be discussing the questions of analog circuits that have come in today's electronics ESE paper. First I will take sir's view on quality of the questions.
In ECE this year, I think the questions are very moderate. Every student I am expecting they have done it well, because there is no indirect questions, they are all direct questions.
Yes sir,
Yeah.
totally 10 questions
Total
have come.
10 questions.
I think all 10 questions you might have answered very well. Okay, I will be discussing first 5 questions and remaining 5 questions Rajkumar sir will take up.
Okay sir, thank
Yes.
you. Thank you sir.
So dear students, let me discuss the first question. It is about 3 statements. This is about small signal AC analysis of BJT amplifier. 3 statements दिए हुए हैं और हमें ये बताना है कि कौन सा स्टेटमेंट यहाँ पर गलत है, which is incorrect, right? Which statement is not correct? Statement 1 is about RE model. RE model or RPi model, these are like small signal models of BJT. This RE model and RPi model, they are actually used for approximate analysis, remember. So statement 1 यहाँ पर हम सही मानेंगे because it doesn't provide exact analysis, it provides only approximate analysis. H parameter model can be used for exact analysis. Okay, we have a exact H parameter model in which we show all 4 components, that input impedance Hi, and one dependent voltage source HR into V2, one dependent current source HF into I1, and one output resistance 1 upon HO. तो अगर आप ये चारों एलिमेंट्स को H पैरामीटर मॉडल में दिखाएंगे एंड इफ यू डू द कैलकुलेशन यू विल गेट एग्जैक्ट वैल्यूज, तो इसको हम कहते हैं एग्जैक्ट एनालिसिस. तो H पैरामीटर मॉडल वी कैन यूज फॉर परफॉर्मिंग एग्जैक्ट एनालिसिस. स्टेटमेंट 2 विल बी करेक्ट and statement 3 says H12. Now please remember H12 is actually reverse voltage gain. It is V1 upon V2 under the condition I1 equal to 0. That H12 is a ratio of input voltage and output voltage. H12 is called reverse voltage gain. But यहाँ पर हमें ये कहा गया है it is like short circuit current gain, तो ये statement गलत होगा. Okay, H12 is a reverse voltage gain. So statement 3 is incorrect. अगर हम options देखेंगे तो अब कोई भी option यहाँ match नहीं हो रहा है, but answer will be only 3 statement. Only statement 3 is incorrect. And in this problem, no option is matching. Okay, if you look at the options, none of the option is matching, but the correct answer is only 3. Third statement is incorrect. Okay, let us go to next problem. Next question is about calculation of transconductance. Okay, transconductance of a BJT. And we know the formula Gm equal to IC divided by Vt, right? In BJT we define transconductance as rate of change of collector current with respect to VBE, and there is a formula for Gm IC by Vt. अब यहाँ पर बेस करंट गिवन है एंड बीटा ऑल्सो गिवन है, तो पहले हम कलेक्टर करंट का वैल्यू निकालेंगे IC इक्वल टू बीटा इंटू IB. ओके, you can substitute beta which is given 104 and base current is given 7.6 microampere. जब आप multiply करेंगे बेटा तो it will become 0.7904 milliampere. Okay, you will get this much milliampere. Then we can say Gm equal to collector current divided by thermal voltage. Thermal voltage का वैल्यू क्वेश्चन में गिवन है 25 millivolt. So if you substitute that, you will be getting Gm equal to 0.0316 एम्पियर पर वोल्ट. अगर आप इसको मिली एम्पियर में कन्वर्ट करेंगे इट विल बी 31.6 मिली एम्पियर पर वोल्ट. ओके, 31.6 मिली एम्पियर पर वोल्ट. सो द करेक्ट आंसर विल बी option C. It was a direct question. Gm equal to IC by Vt. You will get Gm 31.6 milliampere per volt. Option C is correct. Then the next question, it is about rectifier concept, right? We always tell in the class rectifier is important for ESE paper, and there is a question from rectifier here. Consider the following statements regarding rectifier. The transformer needed for a bridge rectifier over full wave rectifier is lighter in weight. That is a correct statement. In full wave rectifier we need center tap transformer which is bigger in size, right, and it is more in weight also. In full wave rectifier we have center tap transformer, it is more in weight, whereas bridge rectifier we use a normal transformer which is lighter in weight. Okay, so statement 1 will be correct. Transformer needed in bridge rectifier is lighter in weight. Then peak inverse voltage of diode used in the bridge is Vmax, and that is also correct. In bridge rectifier we write PIV equal to Vm, right, or Vmax, and full wave center tap rectifier PIV equal to 2 Vm or 2 into Vmax, right, Vm in bridge rectifier and 2 Vm in center tapped full wave rectifier. तो statement 2 भी यहाँ पर सही है बेटा, and statement, that's all, both statements are correct, so correct answer will be option C. In this question we can take answer as option C, दोनों statement यहाँ पर सही हैं. Next, the next question is about biasing concept. We are comparing here FET with BJT in the first statement. DC analysis for FET is simpler as compared to BJT due to linear relation between input and output quantities. This is a general statement. In FET biasing will be easy, okay, and as compared to BJT. So statement 1 will be correct. And statement 2, fixed bias arrangement of JFET has the advantage that it uses a separate supply. Okay, you know the circuit for fixed bias or gate bias circuit. In gate bias circuit we need a extra supply connected to gate terminal like this. In gate bias circuit or fixed bias circuit we need a extra supply, we need this gate supply also, and that becomes a drawback. Okay, so fixed bias arrangement of JFET has the disadvantage that it uses separate supply. तो ये वाला statement भी सही मानेंगे हम. Okay, it needs a extra supply here. And third one, it is essential to establish operating point for BJT when it is used as an amplifier. ये भी statement सही है. We normally keep operating point at center of the load line to get distortion less output. So proper establishment of Q point is important in a BJT amplifier. Statement 3 भी सही है. So in this problem or in this question all the 3 statements are correct. We can take answer as option D. Option D will be correct here. Okay. Then I have one more question here. I think I did one more question. This is about comparison of MOSFET with JFET. Statement 1, we are comparing MOSFET with JFET. Normally MOSFET has higher input impedance as compared to JFET, right? In MOSFET we use insulator silicon dioxide between gate and channel. Because of that insulator MOSFET will be having very high input impedance as compared to JFET. In JFET we do reverse biasing, okay, of gate channel junction, and in MOSFET there is a insulator between gate and channel, and insulator, because of that we get higher input impedance in MOSFET. So statement 1 यहाँ पर गलत होगा. MOSFETs have high input impedance, remember, because of insulator SiO2. And you can also say in MOSFET gate current will be femto ampere 10 per minus 15 ampere. In JFET gate current will be nano ampere 10 per minus 9. तो आप उस तरह से भी कह सकते हैं gate current very low in MOSFET, so input impedance will be high in MOSFET. Next, depletion MOSFET can be used with VGS positive as well as negative. That is a correct statement. Depletion MOSFET has a physical channel. अगर आप इसको positive VGS apply करेंगे it will work in enhancement mode. If you apply negative VGS it will work in depletion mode. Statement 2 is also correct. 2 is correct. Then FET should be biased in saturation region to be used as an amplifier. That is a correct statement. Both JFET as well as MOSFET they are used as amplifier in saturation region. So 3 भी correct है. And we have to tell which statements are correct. So यहाँ पर correct statements are 2 and 3. We can take answer as option C. So dear students, these were the first 5 questions that I have taken up, and there are 5 more questions which my colleague Rajkumar sir will take up. So please.
Thank you, sir. Thank you, sir. Yeah. So, sir has completed up to 8th question. Remaining questions I will complete for you. So, coming to the 9th question. What is the cutoff frequency of the first order low pass filter for R1 C1 they are asking. For any first order low pass filter, the frequency will be 1 by 2 pi R1 C1. This is the formula for the lower cutoff frequency. Okay, low pass filter ka cutoff frequency ka formula. So, if you substitute these values 1 by 2 into 3.14 into R1 he has given us 1.2 into 10 power 3 into C1 0.02 into 10 power minus 6. So, if you substitute these values, you will get the cutoff frequency for this question. According to my calculation, I got this answer as 6.63 kilohertz, 6.63 kilohertz. So, you can check this answer. This is the correct answer for this question, 6.63 kilohertz. So, option B will be the correct answer for this question, option B. Okay. So, let us go to the next question. Question number 28 is related to H parameter concepts. Hybrid parameter H21 is asking. Generally, we try to study in networks also H parameters, in analog also. H21 generally we refer it as forward current gain we call. According to the board, you can see input impedance is given, reverse voltage gain, output impedance. So, the correct answer will be forward current gain will be the correct answer for H21. If it is H12, we call it as reverse voltage gain. Okay. So, option B is the correct answer for this question. Now, question number 62 we are dealing in analog electronics. Consider the following statements regarding semiconductor diodes is asking. So, first statement is said PIV ratings for silicon diode can be in the neighborhood of 400 volts, whereas the maximum value for germanium is closer to 600 volts. The very first point in electronic devices you can understand, for silicon the PIV rating is higher value compared to germanium, but in this statement he is telling germanium has more PIV. So, that is enough to tell you this is a wrong statement. Okay, that is one point. The second one is silicon can be used for the applications in which the temperature may rise up to 300 degrees centigrade. Generally, silicon can withstand maximum up to 200 degrees centigrade, not up to 300 degrees centigrade. So, this is also a wrong statement. Germanium has a much lower maximum rating 100 degrees centigrade. Generally, the typical value of germanium to withstand the capability of temperature is 100 degrees centigrade or below 100 degrees centigrade. So, this is correct answer. So, for question number 62, statement 1 and 2 are incorrect for this question. So, he is asking which of the following statements are not correct. So, I can take the option as option A. So, he is asking not correct statements. So, 1 and 2 you can take it as correct options. Okay. And this is correct answer. So, we cannot take this answer. So, 1 and 2 will be the correct answer for this. Now, coming to the question number 64. Here also it is a statement based question again. Consider the following statement regarding transistor amplifier. Current gain increases with increasing temperature. Generally, current gain in transistors are called alpha beta values. Generally, current gain always increases with respect to temperature. This is a correct statement. Okay. With respect to temperature, it will increases, and VBE decreases about 100 millivolts per degree centigrade. Generally, VBE will decrease by minus 2.5 millivolts per degree centigrade. So, this is wrong statement. And reverse saturation current doubles for every 10 degree. This is a very popular statement every student knows in electronic devices. This is a correct statement. So, 1 and 3 are correct answers. So, which of the following statements are correct? So, 1 and 3. So, option B will be the correct answer for this. Okay. For this question, option B will be the correct answer. Coming to the last question. One op-amp question they have asked in this series of questions. If the input voltage of an op-amp VI1, VI2, they have two terminal input voltage they have given. the differential gain is 4000 and CMRR is 100. What is the output voltage is asking. Generally the output voltage is nothing but AD into VD plus AC into VC. So, this is the total output voltage of op amp. AD is differential gain, AC is common mode gain. If you want common mode gain, it should be AD by CMRR. You will get the AC value. AD he has given in the problem is 4000 by CMRR value is 100. So, it is 40. So, we are getting AC value as 40 here, common mode gain. Then how to find VD? VD is nothing but VI1 minus VI2 and VC is nothing but VI1 plus VI2 divided by 2. VD is nothing but differential voltage, VC is nothing but common mode voltage. You just calculate these answers, so that if you substitute all the data here, you will get the output voltage. Okay. So, I am not calculating it, I am giving the direct calculation answer. I am getting around 45.8 millivolts, 45.8 millivolts. So, this is the expected value I am getting 45.8 millivolts. So, option C is correct answer here, option C. Option C will be the correct answer for this question. So, 45.8 millivolts will be the correct answer. Thank you very much. We have been completed analog questions. The next faculty will come. Thank you very much. Yeah.
Hello dear students, very good evening. This is Vijay Kumar. So, we shall discuss about the microprocessor questions which were given in ESE 2026 for electronics, right. So, look at, so there were number of questions here. So, let us discuss the questions. So, 99 question, that is the microprocessor Zilog Z8000 design. It is a direct question, it is 16-bit microprocessor. So, this is option B. Because Z8 is 8-bit, so it is 16-bit processor, right. Next one, the execution 100, question number 100, the execution of ORA instruction requires. So, OR immediate instruction basic format is ORI 8-bit data, ORI 8-bit data. So, data is 1 byte, the opcode is 1 byte, right. So, it is a 2-byte instruction. So, the first one is operation is there are 2 machine cycles and the number of clocks are T states are 7 T states, okay. So, here if you observe carefully it is 7 T states. So, why it is 7 T states? Because it is a 2-byte instruction. So, first one is opcode fetch, second one is memory read. In the read operation only OR operation is executed with the content of accumulator and the immediate data. So, therefore, opcode fetch is 4 clocks and read operation is 3 clocks. So, 4 plus 3 it becomes 7 clocks, okay, 7 T states. So, here the correct option is 2 machine cycles and 7 T states. Option A is the correct answer. Next one, question number 101. So if one of the following instruction, which one of the following instructions in 8085 processor does not affect the flag? See, flags are affected only for arithmetic and logical operations, right? So rotate operation is a logical operation, so carry flag is only affected. Push is a data transfer instruction, so push register pair into the stack memory, so it's a data transfer instruction. So this is OR instruction, flags are affected. Increment also flags are affected. So for this one, flags are not affected. So it's asking for which instruction flags are not affected. So the correct answer is what? B, option B. Is it understood? So question number 101, the option is B. Next, 103, consider the following statements regarding MC. So this is the microcontroller of which is of Motorola company. So it is like he is asking some features. It has 40 IO lines with multiple functions, that is correct. These are simply features of this. It has two operating modes, one is called as stop and wait, that is also correct. Other one is it has 8 KB of, see there are different variations in this microcontrollers, okay. So it supports the ROM, 8 kilobytes of ROM and more than that also, but that is true. And the EEPROM, electrically erasable programmable read only memories, from 512 to more than that also. So this is also correct statement. So 1, 2, 3 are correct statements. So 103 is also D. Next one. In asynchronous data transfer, one unit receiving the data items responds with another control signals to acknowledge receipt of the data. This type of agreement between two independent units is referred to as. See, when the devices come in asynchronous mode, whenever the transmitter transfers the data to the receiver, so the receiver may not be alert. So whenever it is transferred, it is a serial communication, right? So the initial bit will be always the start bit. So this type of coordination is called as handshake signals. Is it clear? So the devices will be corresponding to each other. That's called as handshaking. Okay. So that is what we call it as the handshake mode of communication. Strobe is only one line. Okay. So the correct option is handshake signals. For example, I am going to start the data, so it will send one start bit. Then the data will go. Then after receiving, it will send one acknowledgement. Okay. Even stop bits go. So that is how the data is transferred. Therefore, after one data is transferred, it will acknowledgement the data. So that is called as handshaking mode. So option is C. 110 is C. The next one is which of the following rules are correct when a transmitted character is detected by the receiver from acknowledge of the transmit. That's now I told you. See, for example, here when the transmitter transmits to the receiver, same, this is also serial communication only. First the start bit goes, okay, start bit, when there is no data, then the line will be at high state. So if I take the diagram like this, it will be easy to understand, okay. So this is the receiver and this one is the transmitter, right? This is the transmitter. So observe carefully, here whenever the data is transmitted, first then there is no data, line condition is high. So one start bit will be transferred, which is always low, because when there is no data, line condition is what? High. Then how many? Some 8 bits of data will be transmitted, and again 1 or 2 stop bits will be present. So this is the rule of data transmission in the asynchronous mode. So stop bits can be either 1 bit duration or 2 bit duration also, based on the mode of operation, right? So one start bit is always low and start bit is always high, and the 8 bits of data will be there. So start bit is always high, okay, right. So this is what he is saying, when a character is not being sent, line condition is high, that is correct. Next one, the initiation of character transmission is detected from the start bit 0, that is always 0, correct. So first is correct, second is correct, the character bits are always follow the start bit. After start bit only the data will go. So this is the data, right? It can be 8 bit data, whatever it is, whatever the mode you have selected. Then the next one is, after the last bit of transmission, a stop bit is detected. So stop bit is also present. So all of them are correct. So the answer is 1, 2, 3, 4. Option D. The next one is in the serial transmission of terminal whose transfer data is 10 characters per second, and each transmitted character consists of a start bit. So one start bit is there, just now we discussed. 8 bits of information is also present and 2 start bits operation is there. It means per one character, how many are going? 1 start bit, 8 bits of data plus 2 stop bits, means how many bits? 11 bits are transmitting. So he is asking for a total of 11 bits, the approximate baud rate. So what is baud rate? How many characters for one character, means for one character, that is 8 bit value, these many bits are going. For 10 characters, how much? 11 into 10, that is equals to 110 bits. So this is what the baud rate is. So this bits per second, or we can say signal transition per second, that is called as simply 110 baud we say. So in serial communication we talk in terms of baud rate, okay, instead of bit rate, right. So that is option A, 110 baud. We talk in terms of baud. Next, in an 8-bit ALU, A is equals to this value and B is equals to some value. After performing A minus B, the compare instruction updates the status bits as. See, observe carefully, this compare instruction performing A minus B. See, actually compare and subtraction both will be in similar way. The only thing is that subtraction and comparison. So, in both of the cases, internally the story is same. Internally subtraction operation is performed, but only thing is that internally subtraction is done, but in subtraction result is stored in the accumulator. In comparison, the operand values are not unchanged, but internal operation is subtraction only. For example, if we subtract this, how does the processor do? In a manual method, how we perform in a manual method of subtraction and in the microprocessor method of subtraction. For example, if I take two variables x and y, x minus y is how we perform. Processor performs as x plus of minus y. X plus of minus y. Therefore, minus y is found by 2's complement method. Okay. So now if we take this this data, for example, say 1 1 1 1 and this is 0 0 0 0. Okay. Now I want to subtract this value. Which value? This b value. So how the processor will be performing? By performing the 2's complement method. So if you take 2's complement of this one, for example, say if you take 0 0 0 1 and this is 0 1 0 0, 1's complement is 1 1 1 0 1 0 1 1 plus 1, that is 2's complement, right? 0 1 0 1 1 0 1 1 1. So how much it is? This value is like EC. So this is 1 1 1 0 and other one is 1 1 0 0. Okay, that is after adding this one. Okay, so we need to add internally. If you add internally, so this is what we are doing. Okay, adding the 2's complement of the second one. So 0 0 1 1 and this is 1 1 plus 1 0 1. This is 1 1. This is 1 1. So this is carry flag which is generated, but in subtraction operation the carry will be automatically complemented, that will be 0. So therefore now if you check the flags, observe carefully here, the carry flag is internally complemented. Is it understood? The result in the accumulator will not be this value, result will be F0 only, this value only, but the internal operation is subtraction operation, therefore flags are calculated by the internal result only. Therefore carry flag will be automatically complemented in the internal subtraction operation. So carry flag is 0. So here carry flag is 0 and sign flag is 1. So carry flag 0, sign flag 1, there is no option here actually, to be frank. So this value must be actually complemented. So actual answer should have been something like carry flag is 0, sign flag is 1. This is sign flag. So if you look at the pattern of flag register, sign 0, AC, parity and carry. So carry flag is 0. Why carry flag is 0? You are simply subtracting a smaller data from the bigger data. There is no carry. So here we call borrow as carry only. Okay. So this is 0 only. Sign flag is 1. Okay. So there is no option called as sign flag 1 and carry flag is 0. You observe carefully. So therefore the options are something little bit ambiguity. So this is the actual answer, and the other one is like other flag is which one? Overflow flag. So overflow flag, if you observe, overflow flag is XOR operation of last two carries while adding. So if you take this one, so if you take sign data, this data is sign data, so here also we got carry, from here also we got carry. So if you take XOR operation of C7 and C8, that is 1 XORed with 1, it is 0. So overflow flag will be 0. So there is no overflow flag here, but even then he has asked, so overflow flag will be 0, and the other flag 0 flag, result is a non-zero value, it is 0 only. So there is no option here actually, to be frank. So here carry flag is 1, it is internally complemented, and overflow is 0, overflow is 0, 0 flag is 0 and sign flag is 1. So this should have been 0. So this is little bit of ambiguity, this is the question. Okay, this is the actual answer. So I hope you have written well. Thank you so much for your wonderful cooperation.
Hello everyone. welcome to this question paper discussion, electronics part. In that control system subject is what I am taking up. Hope you all might have done well in today's exam. Coming to the exam pattern, which is highly unpredictable. Everyone knows that engineering service is unpredictable. This time more questions are from the theory. Almost all the questions are from theory part, very less of numerical. In control system we have 10 to 11 questions. I think 1 or 2 numerical, the remaining all are theory based question, which makes the paper to be lengthy. So based on this, I consider it to be a little bit tough compared to the last year. So it is taking time for the students to solve the question, and not just about control system, almost all the subjects are students and teachers are of this opinion that they are more biased towards theory questions than numerical. So it makes paper lengthy. Yeah, coming to this question, control system questions. Consider the following statements regarding Mason's gain formula. Pk is the forward path transmittance, that means gain of the kth forward path from a specified input node to an output node. This is the gain of the kth forward path. That's correct statement. Second one, delta is the graph determinant which involves the closed loop transmittance and mutual interaction between the non-touching loops. Yeah, delta determinant of the signal flow graph. True statement. Third, delta k, it is the determinant of a particular forward path. Removing that from the signal flow graph. What does it mean? Delta k is defined to be 1 minus sum of all the individual loop gains that are not touching to this particular forward path. It means the forward path is excluded and the remaining part of the signal flow graph is discussed. That is delta k. That's correct. All 3 statements are right. Which of the following statements are correct? All 3. Option D. That's the explanation of Mason's formula. Next, the root locus starts for k is equals to 0 from the open loop poles and terminates for k is equals to infinity on the finite open loop zeros only is a false statement, because when k tends to infinity, the root locus terminates either at open loop zeros that are finite or those open loop zeros that are at infinity. Right. Second, for the higher values of gain k, the root locus can be approximated by asymptotic lines, and these asymptotic lines intersect at a point known as centroid is the correct statement. As gain tends to infinity, root locus branches tend to infinity along asymptotes, and all these asymptotes will meet at a point called centroid. If the root locus intersects the imaginary axis, then the point of intersections are conjugate. Right, whenever root locus intersects geometric axis, then it will be complex conjugate points. Second and third statements are correct. 2 and 3 only. It's about which statement is correct. 2 and 3. Next, consider the following statements regarding the stability in terms of the characteristic equation of a control system. If any oscillations set up in a system in consequence to application of an input are damped out with respect to time, then the system is said to be stable. So if at all if a system indulges into oscillations upon applying the input, and later if those oscillations die out like an under damped system is stable. If the magnitude of the oscillations is sustained, then the system is unstable is false, because if the magnitude of oscillations are sustained, then the system is marginally stable. For a stable system, there should be no change of sign in the first column of Raut array. Yeah, that's true. Right, then only it is stable. So 1 and 3 statements are correct. 1 and 3 only. Consider the following statements. Consider the following statements regarding the frequency domain analysis of control system. Gain margin is used to indicate the proximity of the intersection of the negative real axis made by the Nyquist plot with respect to -1, 0. Yes, see, the point at which Nyquist plot intersects -1, 0, from that point, the distance of -1, 0, that's what graphically gain margin, that intercept and -1 ke beech ka difference. That's true statement. Phase crossover frequency is the point in the G of j omega plane at which the Nyquist plot intersects the positive real axis is false, because phase crossover frequency is the frequency at which the phase of the system becomes -180 degree. So it has to be negative real axis, not positive real axis. Third, gain margin is the amount of the gain in decibels that can be allowed to increased, is the amount of the gain in decibels that is allowed to be increased so that the system, before the system becomes unstable. If gain increases, then gain margin decreases and the system travel towards instability. So gain margin is the amount of the gain that can be increased, whether it is in decibels or non-decibels, both way. In case of decibels, it will be increased by getting added. If it is not in decibels, it will be increased by getting multiplied. Either way, it is called increase only. So gain margin is the amount of the gain that can be increased by the system travel towards instability. That's right. This is correct statement. So 1 and 3 are correct. Which other statements are correct? 1 and 3 only. 1 and 3 only. Consider the following statements regarding the principles of control system. In control system, controlling variable is the excitation applied to a control system from an external source. Controlling variable. It's not the variable to be controlled. People get confused here. Controlling variable. Who controls the control system? The command given to the system. Like, to an AC, when we set 20 degrees centigrade, now that command which comes from an external source, that is controlling the AC to maintain the room temperature at 20 degrees centigrade. And it is independent of the output of the system, obviously. Right, whatever be the output, the command remains to be the same. One of the important features of feedback is to reduce the sensitivity. Yeah, that's right. One of the features, reduce the sensitivity. Third, in the system, the actuating signal is the difference between the reference input and the correct. All three statements are right. The steady state error for type 0, type 1 system for parabolic input. See, parabolic input, steady state error of type 0 system is infinity, type 1 system is infinity, type 2 system is finite, type 3 system onwards it will be 0. We have a table. So it will be infinity and infinity. Consider the following statements regarding feedback compensation. See, the design procedure for series compensation is more direct compared to that of feedback compensation. In case of feedback compensation, a great calibration is required looking at the system parameters. It's a bit tough compared to the series compensation, which can be directly connected to the plant. That's true. Faster response can be achieved by parallel compensation. In case of feedback compensation, first output has to come and then it has to be measured and through feedback, and then it has to be fed to the along with the input, the error is calculated and then the final response comes. In case of parallel compensation, signal flows in both the directions forward, two paths se jaake na final output banega. It is faster, that's correct. The degree of accuracy and stability of control system can be improved by the use of series compensation. You see, PD controller, PI controller, they are mainly used in series. PD is for a better degree of stability, PI is for a better degree of accuracy, series compensation is better. And in feedback, it is only derivative controller that we use, and derivative controller increases the error. It means it reduces accuracy. Right? So this is better. All three statements are correct, which are correct, okay? All three. The stability limit of a servo mechanism with the open loop transfer function. Obtaining the characteristic equation S cube T2 plus S square plus S T1 Ka plus 2 Ka is equal to 0. For a third order system to be stable, product of these coefficients must be greater than that. So T1 Ka must be greater than T2 into 2 Ka. So T1 greater than 2 T2. T1 greater than 2 T2. Option C is correct. How many number of roots are there on the right side of S plane for the system whose characteristic equation is given below? S power 6, 5, 4, 3, 2, 1, 0. 1, 1, minus 2, minus 3, minus 7, minus 4, minus 4. Minus 2 plus 3, 1, minus 7 plus 4, minus 3, minus 4. 0, 0. A row is becoming 0 completely. Auxiliary polynomial. Differentiating. 4 minus 6 minus 12 plus 6 minus 6 by 4 minus 3 by 2. minus 6 by 4 minus 3 by 2 and then minus 4. This is 9 plus 16, 25 into 2 by 3 minus 4. So we have one sign change. So that means one root is in the right side of S plane, option B. Consider the following statements regarding time response analysis of control system. In proportional control, the actuating signal for the control action in a control system is proportional to the difference between the reference input and the feedback. See, the difference between the reference input and the feedback, that is the error signal. So actuating signal, which is output of proportional controller, is proportional to the error signal. That's true statement. Second, the sluggish overdamped response of a system can be made faster by increasing forward path gain, zeta inversely proportional to root k. If this increases, zeta decreases. So if the zeta of the overdamped system decreases, it tend to become critically damped or underdamped. So that tend to become faster. That's true. Third, without sacrificing the steady state accuracy, the maximum overshoot can be reduced. Is it possible? Yeah, PD controller can help you to reduce the overshoot without sacrificing the accuracy. That's possible. All three statements are correct. That's all about this. So as you see, 1 or 2 are numerics, rest are all theory questions. So that's what makes students to feel this paper to be lengthy. Of course it is. Thank you so much. The next subject starts soon.
Good evening, dear students. This time the 13 questions from the network analysis. The toughness is moderate to tough. The questions are, so most of the questions are theoretical as compared to there is a numerical. Okay. So we are going to solve the questions now. The first question, consider the following relation for the two port networks. So this will take a more and more time actually if you are doing the A पैरामीटर के लिए और H2D के लिए ज़्यादा टाइम होता है. ये टाइमर क्या कर सकते हैं? सो बेस्ड ऑन द ऑप्शंस एक है, बेस्ड ऑन द यूनिट्स देन यू टू चूज द आंसर नाउ. इसमें क्या है, A इज इक्वल देख लो, ए इसका यूनिट्स क्या है V1 by V2, सो V1 by V2 में नो यूनिट्स है, इसलिए H11 का यूनिट्स क्या है ओम्स है, एंड ईयर का सीमेंस है, H22 इज, सो अभी मैं लिख रहा हूं इधर इस H11 is ohm and this is Siemens, so it becomes a now no units. H12 is already current gain and voltage gain, this is no units. H2 also no gain, no units, so it was a no units for this one based on the here no units. And H22 is क्या है, H22 is equal to I2 by V2, H22 units are Siemens होना चाहिए, Siemens, but here Siemens already, this is Siemens and Siemens and Siemens, okay, by Y2 and also Siemens, so Siemens square by here Siemens, here क्या हो सकता है Siemens square minus Siemens square by Siemens, so here 1 Siemens will get, okay, so H22 is Siemens. But if you do this AD minus BD by, this also not a correct, AD is a no units and BC is a no units by D as also no units. So based on this you do this, relations are not correct hai. This relation is not correct, this relation is not correct, only one relation is correct, but here is something is, here minus होना चाहिए, इधर plus होना चाहिए, but according to question में ये answer में mistake दिए थे, इसीलिए here is the relations are not correct, these two are relations are not correct, based on this you can say here 1 is a correct option whenever is a minus here put. So based on this 2 and 3 are the not correct relation hai, 2 and 3 only, okay. Next is consider the following statements regarding two-port network. Two-port regarding is क्या है, the overall Z parameters matrix for the series connected two-port networks are simply the sum of Z matrices each individual. So series के लिए ZA plus ZB हो सकता है ना, Z total is equal to, series में ZA plus individual Z parameters you can add directly, this is correct. The overall Y parameters is two networks A and B are connected parallel के लिए directly, sum are not, simply the summation of the Y total is equal to directly YA plus YB are not. Parallel के लिए Y parameters are suitable and series के लिए Z parameters suitable and ABCD parameters for the cascade के लिए suitable है. So ABCD parameters cascade में, so total transmission parameters are is equal to TA into TB. TA into TB. Check करो, here is a cascade connected two-port, it is a product of, so 3 statements are correct or not, above statements are correct, 1, 2, 3 statements are correct, 1, 2 and 3 are the correct options. Anyone है क्या इसमें, so any live में क्या, so you give answer now fast. So now consider the following statements is based on the graph theory is given. Chord is nothing but link, is the branch of the graph that does not belong to the particular tree. कब बोल सकते हैं chord और link, tree बना after formation of tree, the removing branches are called chord बोल सकते हैं, that is a link बोल सकते हैं. Is statement is correct or not? Yes, chord is the branch of the graph that does not belong to the particular tree, is correct. Cut set is, what a cut set, fundamental cut set में क्या रहते हैं, फंडामेंटल कट सेट में एक ट्विग रहते हैं, रिमेनिंग आर लिंक्स रहते हैं, रिमेनिंग आर कॉर्ड्स रहते हैं. कट सेट इज अ यूनिक सेट विथ रेस्पेक्ट टू ए गिवन ट्री ऑफ ए कनेक्टेड ग्राफ कंटेनिंग वन कॉर्ड. ये रॉन्ग है, वन कॉर्ड नहीं होना चाहिए, वन टाई सेट में कॉर्ड होना चाहिए, बट कट सेट में क्या होना चाहिए, a twig होना चाहिए, and all of the free branches are contained in the free path formed between two vertices of the chord. So cut set is a unique set with respect to the given tree. This is a cut set. This is forming, suppose I am taking this example, if you cut it, in this cut tree of connected graph containing one chord, here is containing only one twig hai, so this is a wrong statement. If M represents the number of branches hai, N represents the number of nodes hai, minimum number of variables are involved in analyzing the network is equal to M plus N minus 1 है क्या. सो इसमें नंबर ऑफ लिंक्स इज इक्वल टू क्या है, नंबर ऑफ लिंक्स L इज इक्वल टू B माइनस N प्लस 1 पढ़ते हैं। B के प्लेस में क्या दिए, M दिए, सो M माइनस N प्लस 1 होना चाहिए, बट इस गिवन क्या है, M प्लस N माइनस 1 दिए, इसलिए ए बी रॉन्ग स्टेटमेंट है। So you are asking about which statements above are not correct. Not correct क्या है, 2 and 3 are not correct, 1 is correct option है, so 2 and 3 only. Okay, कोई भी दिए क्या answers? Should be number of branches. Anyone? Next is the incidence matrix of the graph. Direct incidence matrix में क्या है, the column of the matrix, the sum of the algebraic sum of the column of the matrix 0 होना चाहिए, that is needed for choose the option होना चाहिए। इसमें देख लो 1 minus 1 0, 1 minus 1 0, 1 minus 1 0, 1 minus 1 0, 1 minus 1 0 करेक्ट है। इसमें देख लो ए नहीं है, सो इसलिए ए ऑप्शन निकाल सकते हैं। इसमें देख लो यार इसमें भी निकाल सकते हैं, -1 ये भी नहीं है, सो यार -1 ये भी नहीं है, सो क्या होना चाहिए, ये इज ऑप्शन डायरेक्टली द इंसिडेंस मैट्रिक्स में सम ऑफ द अलजेब्रिक सम ईच कॉलम ऑफ द मैट्रिक्स क्या होना चाहिए, 0 होना चाहिए, सो ये इज द ऑप्शन। नेक्स्ट इज कंसीडर द फॉलोइंग स्टेटमेंट्स रिगार्डिंग द सर्क्यूट थ्योरी। द अलजेब्रिक सम ऑफ द रो entries of incidence matrix is 0. The algebraic sum of row entries, these are the row entries or not, this row entries, these are column entries, row entries are not 0, so here is row entries are 0 diye, so row entries are not 0. The determinant of the incidence matrix of the properties of incidence matrix में क्या है, the algebraic sum of column का 0 होता है, एंड ऑल्सो ए डिटरमिनेंट क्या होता है क्लोज लूप में, ए 0 होता है। कोई इंसिडेंस मैट्रिक्स ले लो, इसका इंसिडेंस मैट्रिक्स का डिटरमिनेंट विल बी गोइंग टू दी 0 है। एग्जांपल मैं बोलता हूं, दैट इज दिस इज नाउ क्लोज लूप है, ले लो एक का, ईयर इज ईयर 1 ईयर 2 एंड 3 ले लो। इफ यू आर फॉर्मिंग ए इंसिडेंस मैट्रिक्स, इसका डिटरमिनेंट विल बी गोइंग टू 0 हो सकता है, इज करेक्ट। ए फंडामेंटल टाई सेट graph with respect to the tree is a loop formed by only one link associated with other twigs है। कोई भी ले लो, इसमें this is now tree, these are the links, so this is now fundamental tie set matrix में क्या रहते हैं, twigs रहते हैं, only one link रहते हैं, remaining are twigs रहते हैं, ये करेक्ट है ना, only one link associated with the other, so ये भी correct है। which of the statements are correct है, so 1 2 and 3 are the correct है, C is the correct answer for this one। इसके लिए डायरेक्टली आप कोई भी इंसिडेंस मैट्रिक्स लेकर इसका डिटरमिनेंट फाइंड आउट करो, कोई क्लोज लूप का, यू गेट ए 0 ऑप्शन आते हैं। नेक्स्ट इज व्हाट इज द वैल्यू ऑफ अल्फा फॉर द गिवन सर्क्यूट व्हेन द पावर लॉस इन 1 ओम रेजिस्टर इज 9 वाट्स होना चाहिए। 9 वाट्स, 1 ओम में 9 वाट्स के लिए देख लो, 9 वाट्स मीन्स सो P इज इक्वल टू I स्क्वायर इंटू R, ओके। नाउ I इज इक्वल टू P बाई R अंडर रूट आर नॉट, अंडर रूट P इज इक्वल टू हाउ मच, 9 वाट्स, 9 by 1 under root is equal to 3 amperes or not. The current of the 1 ohm resistance is 3 amperes. So this is 5 amperes, the 3 amperes remaining current I2 is equal to how much here now, 2 amperes directly बोल सकते हैं। Here asking the question is alpha value होना चाहिए। Then the power absorbed by the 1 ohm resistor is 9 watts है। So I2 is A branch में how much current is flowing, 2 ampere. How to find out this branch current? This current is 3 into 1 is 3 volts. This voltage is here already the how much is given, 15 volts here now. The voltage will be here 15 volts directly. 15 volts हो गया. So now the current is flowing from here to here. What is the now current equation? I2 is equal to 3 minus 2 plus alpha I1 minus 15 by resistance value is 2 ohms. So 2 ohms हो गया. What is I1 value is, I1 value is given, I1 is current from the 1 ohm resistance, I1 value is 3 amperes. So I1 is equal to 3 है. So 3 plus here I2 is already know that 2 is equal to 3 plus 3 I1 minus 15 by 2. So from this you get a I1 value is here is a I1 here alpha value will get, so alpha into 3 this is alpha into 3 here. After simplification you get a alpha value is equal to nearly equal to 5.33 will get. So answer is D. Okay. So this is about the alpha value is. So direct look at a 16 by something 3. So based on that you can get a 5.33. Okay. So remaining problems, so the Kiran sir will discuss. Okay. Thank you.
Good evening, dear students. Come to the next question. In this example, what is your requirement is the I1. Let's check it out. If you transform this network, in the S domain, देखो जी, can I draw like this here? What the Laplace of this constant is a V by S. Now in the statement it is given, it is not having the any initial values, inductor are not having the initial values. If you convert into S domain, resistance will remain same. Now what about this inductor? We read this as a Ls. Now correspond is given information, what the loop 1 current is the I1. What is the loop 2 current? Loop 2 current is the I2. Simply can you write the respect to the KVL equations? Can you write the respect to KVL equations for this one? If you go for the respect to KVL equations for this one, देखो जी correspond loop 1 source voltage V by S, जो अपना resistance R1 है ना, I1 is the downwards, but whatever is the I2 is the upwards, opposite direction. Then we can write this as a minus I2 into R. Now equation 1 is completed. Equation 1 is completed. Can you apply the similar procedure for the loop 2 also? Correspond loop 2, जो I2 है ना, I2 circulates in the inductor R2 and the R1. Then we can write this one as a R1 plus R2 LS. Now correspond this R1 resistor, this I1 is the downwards, I2 is the upwards, opposite direction. Opposite direction means what is the sign for this one is the minus. Equation 2. देखो जो question में what is asking the I1 value. To get this I1 value from this equation 1, then what you have to eliminate the I2 you have to eliminate. To eliminate this I2 value, can you take the help of this equation 2? Can take the help of this equation 2. Now if you rearrange this equation 2, can I write this here I2 equal to जो result है ना, give this one equation 3. Now just substitute this equation 3, जो अपना equation 3 है ना, equation 3 ले जाके equation 1 में put करो, simplify करो, simplify करने से anybody give answer for this one? बोलो जी, anybody give answer for this one? Anybody answers? Substitute that equation 3 in equation 1. check करो जी, answer is a C. Simplify करो, simplify करने से you'll get the answer. Okay? Okay, come to next question. Can read the statements you have to read carefully. देखो जी, first one क्या है इधर, passive network. What the meaning of this passive network is it does not consist of any sources. Statement is correct. Now when it is not having any sources, simply we can treat that one as a load. Statement is correct. What about the next one? Physically, if you are able to separate, the resistor, inductor and capacitance, now we can name this as a lumped element. That means the second statement is also correct. Come to third statement. Now correspond this third statement, if the same network is repeated, we can call it a recurrent network. It is also correct. That means sir, all the given statements are the correct. Okay. Yes. Some if you come to the some questions are little lengthy hai. Yes, I accept that one. Not all the questions, only few questions. Can you read the statements first? देखो in this one, what is the statement given as a asymmetrical pi section? Now question में क्या पूछ रहे जी? Which of the following statements are the correct? Now shunt or impedance are the not identical. देखो जी, correspond this example. If you indicate like this, suppose if I give the name like this, RA, RB and the RC. देखो जी, correspond symmetrical के लिए क्या चाहिए? इधर RA and RC should be exactly identical. Shunt branch parameters should be identical. But what is the statement given as a unsymmetrical network configuration? Shunt branch impedance are the not identical. Yes, symmetrical तो identical होना है, unsymmetrical means not identical. That means the first statement is a correct. जो अपना पाई नेटवर्क है ना, आप दूर से देखिए इधर, it is one closed loop. With that closed loop here, we can also name this as the O network. That's why O section. It is also correct. Because in this one, closed loop is the present. It is one type of O section. What is the next one is a L section. In this example, what is the statement given as a? देखो जी, a particular question में मान लो आप इधर R3 को हटा. If I remove this R3, so if I remove this RC, if you observe this part of this network shape कैसा है जी? L shape है. That means it is also correct. L section. If you remove one of the shunt branch element, remaining part of the network is a L section. That means here also all the given statements are the correct. Okay. Come to the next one. What about next one is the H21. If you come to standard equation क्या है इधर? It is our standard equation. In this one, if you want to find out the H21 equal to, how do you write this as a I2 by I1. Condition क्या है? V2 should be equal to 0. That means we are getting as a current gain. That means as per the given statement, sir, voltage gain is incorrect, admittance is incorrect, what about the impedance also incorrect. Now current gain, that means here the second option is the correct. Okay. Come to next one. Now correspond this example here, 2.2 is a reciprocal. Reciprocal के लिए if you come to Z parameters के लिए, what reciprocal condition is the Z12 is equal to Z21. What about Y parameters के लिए? This Y12 is equal to Y21. Now what about this hybrid parameters? Hybrid parameters के लिए this H12 equal to minus H21. But if you come to ABCD parameters, what is the condition is the AD minus BC equal to 1. That means here as per this one here, if you rearrange this expression, now last one is satisfying. Okay. Come to the next one. Which of the following statements? In this one, क्या चाहिए आपको? Which of the following statements are the not correct? Can you give your answer here? Anybody give the answer for this in question number 30? It is one good question. Which of the following statements are not correct? Okay, let's check it out. If you observe the first statement carefully here, indirectly statement given as a correspond to reciprocity theorem. Now as per reciprocity theorem, the given first statement is a correct, but क्या चाहिए आपको? Which one is a not correct? Now correspond to second one is here symmetrical. To satisfy the symmetrical condition, this voltage and current should be does not altered, but it gives the statement as a altered. That means sir it is a one of the incorrect statement. As per given question our requirement is which one is the not correct, which one is not correct. To satisfy symmetrical condition voltage and current interchange करने के बाद we have to maintain the same magnitude, we should not alter, but here the statement is altering. What is the next one is symmetry. For symmetry what is the condition for this? The Z11 is equal to Z22, but here one negative sign is present, it is also incorrect statement. That means here C is the correct option, second option, third options are the incorrect. Can you verify this last one? Now in this example here voltage source here इधर क्या चाहिए आपको, which are the correct statements. Now correspond to voltage source always resistance in the series, not in the parallel, but in the statement is given as a voltage source in parallel with the resistance. First one is the incorrect statement. Come to second statement, current source I in parallel with the resistance. If you come to the practical current source, resistance is connected, resistance connected in parallel to the current source, first statement is correct. But the one more point is voltage source means resistance is connected in series, second statement is correct. Come to third point, dependent sources. The main purpose of the dependent source is it is utilized for the analysis of the electronic devices, that means it is also correct. इधर क्या चाहिए आपको, correct statement चाहिए, that means second one and third one are the correct. Okay.
So this year if you see the communication systems questions, I felt a bit of lengthy because all the questions are unexpectedly, all the questions are theory questions, okay, not even a single problem, okay, except one question I think. So all the questions are theory questions, so I felt bit of lengthy because you have to read all the statements, okay, but questions are within the reachability only except the few, okay, but I felt bit lengthy. I felt bit lengthy, yeah, ठीक है. So let's proceed with the questions. So this question is a direct question, and this is about CRC. Okay, we already done in the classroom. Here the data word is given, and here the divisor constant is also given, and which of the following is the CRC code you need to find out. So what you can understand CRC code based on the given options, it will be the transmitted code word. CRC code means transmitted code word we need to find out. So what is the procedure for this? The divisor is having how many bits here? 5 bits. So then you have to append 4 zeros, okay, to this, like after adding 4 zeros, this is 1 0 1 0 1. If it is having 5 bits, 5 minus 1, एक 1 को कम करना है, 1 कम करना है उससे length से, so length of 5 है, so इससे 1 कम करने तो that will be 4, so you need to append 4 zeros like this, and no, this is actually you have to append this 4 zeros to the data word. The data word is what here? 1 1, yes, 1 1 0 1 and 0 1 0 1 1 0 1 0 1 0 1 0. Okay, so for this data word you need to append that 4 zeros you need to append, and you have to divide this with the divisor constant, that is 1 0 1 0 1, and this is XR division, okay, or modulo 2 division I can say. This is 1, then it is 1 0 1 0 1, आप XR addition करना है, so 1 plus 1 0, and this is 1 1 and 1 1 XR addition, and you have to bring down the remaining bits को भी आप okay नीचे लाना है, 1 0 1 0 and 4 zeros like this, and discard this initial 0 and start with the 1, discard the initial zeros and start with 1, and again 1 hoga, this is yes, and again 1 0 1 0 1 like this, and do XOR addition and continue this procedure, and finally you will get what is the remainder you will left with is 0 1 0 1 1. Yes, as I said, you have to discard the initial 0. So what is the remainder we left with here is 1 0 1 1. You can't do further division because here the divisor is having 5 bits and the remainder we left with 4 bits. So this is actually CRC हम इसको बोलते हैं. Then what is the transmitted code word? Transmitted code word will be, yes, this is actual data word, है ना, 1101. This is 0 1 0 1 1 0 1 0 1 0 1 0, and this 4 zeros which we appended replace with this CRC से replace करना है, and this is the transmitted code word, और इसको भी हम CRC code भी बोलते हैं. So what is the correct option is D will be the correct option for this. So yeah, D is the correct answer. Good. And if you see, this is the bandwidth of QASK. The QASK, this is also called as QAM. QAM. What is the bandwidth of QAM? This is 2 RB upon log m base 2. But the catch point here is it is the bandwidth of MRA QAM or MRA QAM or MRA QASK or MRA PSK. The bandwidth will be same only, and that is 2 RB upon log m base 2. This is where the binary sequence represented with the rectangular pulses, and if it is represented with sync pulses, the default will be sync pulses. Then you have to replace RB with RB by 2. Then the bandwidth you will get is, this is RB upon log m base 2. This will be, and here log m base 2, it actually specifies the number of bits per symbol. So log number of bits per symbol, that number of bits per symbol he is denoting with n here. Capital N specifies number of bits per symbol. Okay, so and RB ko he is denoting with FB here. Okay, and so which option is correct is option D is going to be correct. Okay, here log m base 2 specifies number of bits per symbol. Each symbol is having how many bits in it. Okay, and that is denoting with capital N here is what you need to understand. And this is about the general question, like if you solve the previous questions of ESE prelims, you might have come across this. So here, which of the following statements are not correct? Okay, so the short noise having a uniform power spectral density. Yes, the power spectral density of short noise. So short noise, the formula will be 2. This is I DC. DC is the direct current here, and 2q, this is एक formula है short noise का power spectral density का 2q IDC, where q is the electron charge, that is 1.6 into 10 power minus 19 coulombs, and IDC is the direct current. You can see the short noise ka power spectral density is independent of frequency, so it is, you can understand this is the uniform, it is having uniform PST. And for the amplifying devices, the short noise is inversely proportional to the output current. So इसका मतलब, इनका ये मतलब है कि short noise is inversely proportional, means it is the RMS current, you can understand. This is I RMS. The default of just the short noise is inversely proportional, means the RMS current of the short noise, that is the default you need to understand. इसका एक formula है, this is same like 2q I DC, it is delta F. Delta F is over which frequency range you are finding this, over which bandwidth you are finding this RMS current of short noise, this is what. And it is proportional to output current, it is given, but it is yes, it is inversely proportional to output current is given, but it is directly proportional to square root of the direct current here, but it is given inversely proportional to, this is incorrect. And so if you see the partition noise, okay, एक noise है partition noise, it is in a diode will be higher than in transistor, this is incorrect. Okay, the number of terminals ज़्यादा है तो एक device में the partition noise भी ज़्यादा होगा, कितना partitions है device में. So here 3 terminals हैं transistor में, here इसमें okay 2 ही terminals हैं, एक ही partition होगा, so partition noise actually transistor में ज़्यादा होगा diode से compare करने पर. So this is incorrect. So which statements are incorrect is 2 and 3 are incorrect, so option C will be correct for this. Okay, yes. Next, if you see the next question, yes. So it is about the white noise, and here which of the statements are correct here. This is which of the statements are correct. So the white noise contains all the frequency components in the equal proportion, that is correct only. Okay. So white noise का कोई partials नहीं है, it will distribute the power equally to all its frequencies. So the Johnson noise is an example of white noise. Yes, that's true. The white noise is also called as Johnson noise. So the white noise is having Gaussian distribution. Yes, that is correct. So 1, 2, 3. So option D will be correct. So I hope you given correct answer for this. And 130 this question, if you see, it is about random variables, a discrete random variable. This is which of the statements is correct here. Okay, a discrete random variable will have a countable number of distinct values. Yes, that's true. The continuous random variable is designed for the system which generates a finite number of outcomes within a finite period of time. This is incorrect. Okay, continuous random variable, you can expect uncountable number of possible values, a range of possible values, but it is given finite number of possible values. So which of the following statements is correct? One only. So option A will be correct for this. And if you see this question, and this is regarding the modulation, analog modulation requires lower bandwidth than that of digital modulation methods. Okay, this is actually not requires lower bandwidth. Yeah, that is correct. Yes, because the main problem with the digital modulation schemes, the main disadvantage of digital modulation schemes is it demands for higher bandwidth than analog modulation, and this is the advantage of analog modulation, it requires a lower bandwidth. And yes, and the separation of signal from noise is not possible in analog modulation. Yes, that's true. The first part is correct only. The separation of signal from noise is not possible in analog communication. Okay. Therefore, repeaters can be used. Repeaters you can understand as a regenerative repeaters. Okay. Regenerative repeaters, though actually first part is correct only, but the second part is incorrect, because regenerative repeaters will be used in digital transmission only, not in analog transmission. So if you see the complete statement, this is incorrect only. FDM is used for multiplexing in analog modulation. Yes, that is correct. So 1 and 3, this is, yeah. So all the questions looks to be easy questions only. This is very simple statements there, but you need to read the statements. You see, it will take time, a bit of time. Okay, it will take little more time, but the questions are simple only from communication systems. And this is, if you see the previous ESE prelims questions, it is a repeated question only. It is about low level modulation, high level modulation. Okay. Yes, which of the statements are correct here? In low level modulation, linear amplifiers are required in order to avoid any waveform distortion. Actually, this is correct statement only. High efficiency class B amplifiers are used in high level modulation. Actually, high efficiency class B से compare करने पर class C में होगा. Actually, high level modulation में, yes, high level modulation में class C amplifiers will be used actually. Okay. Class C will be used, not class B, because class C amplifiers are having higher efficiency compared to class B. So it is actually not correct. In high level modulation takes place in last RF amplifier stage of the transmitter. Yes. So in low level modulation may the amplification will be offered in the initial stages, whereas in high level modulation the amplification will be offered in the last stages actually. So which statements are correct here is 1 and 3. So this is B will be correct. Okay. And if you see this question, which of the following statements are correct here? Synchronous detectors suffer with the diagonal clipping occurs. That is not correct, because diagonal clipping occurs in envelope detection. Okay. The operating principle of envelope detection is to rectify the incoming signal and then and pass it through low pass filter. Yes, this is true only. Okay. If you see the circuit diagram, it's a kind of rectifier and followed by the low pass filter and then passing it through low pass filter. Envelope detector is used for DSP-ESE. It's not true. Envelope detector is used for only for AM demodulation. So which of the following statements are not correct? So 1 and 3 are not correct. So C will be correct. And if you see, this is which of the following statements are not correct. Okay, frequency discrimination method can be used to generate SSB at higher frequency. This is actually not correct. The thing is, in the frequency discrimination method, first we it is also called as filter method. First we generate DSBSC and इसमें दो side bands होगा, उसमें हम एक side band को select करते हैं by using proper low pass filter. And हम एक ideal filter को use करना है, then only हम properly एक side band को separate कर सकते हैं. And if you see at higher it was given higher frequencies. At higher frequencies में the filters which are used at higher frequencies, that high frequency filters के लिए the quality factor कम होगा. If the frequency of the resonant frequency of the filter is very high, then the quality factor is going to be less. The quality factor less है तो sharp transition नहीं होगा उस filters का, then वो properly side bands को separate नहीं कर सकते हैं, because high frequency filters के लिए quality factor कम है, इसलिए quality factor कम है तो sharp transition नहीं होगा filter का and proper से हम divide नहीं कर सकते हैं side bands के लिए side bands को, इसलिए frequency discrimination method generally it is used to generate SSB at lower frequency, not at higher frequency. Up conversion is needed in phase discrimination method, nowhere. आप फेस डिस्क्रिमिनेशन मेथड का ब्लॉक डायग्राम देखने पर उधर कोई अप कन्वर्शन नहीं होगा. एंड इन फ्रीक्वेंसी डिस्क्रिमिनेशन मेथड अनवांटेड साइड बैंड इज कैंसल्ड आउट बाय शिफ्टिंग AF एंड RF सिग्नल्स टू बैलेंस modulator by 90 degrees. Yes, this is correct only. If you see the phase discrimination method, here AF and RF signals means it is message signal, and this is message signal, and it is going to be the carrier signal. RF signal means carrier signal. एक modulator के लिए, एक balance modulator के लिए we give AF and RF signals directly, and another balance modulator के लिए, or that is also called as product modulator, we give AF and RF signals with 90 degrees phase shift, so that one of the side bands will be cancelled and only one side band we will get in the final output. So here which of the statements are not correct is which of the statements are not correct? 1 and 2 are not correct, so A will be the correct answer. And if you see which of the following statements are not correct, this is what I am saying, all the questions are which of the following statements are correct or incorrect, so like that questions were framed. So not correct. So noise interference is minimum in PAM, that is incorrect. PAM, that is pulse amplitude modulation, where the amplitude of the pulses will vary according to the variations of the message signal. So in PAM, message information will be stored in the form of amplitude variations, where amplitude of the signal will be highly disturbed with noise interference. So actually noise interference PAM में ज़्यादा होगा, इसमें minimum दिया है. Next, the instantaneous power of the transmitter remains constant in PWM, 9. PWM, the name itself indicates pulse width modulation. The width of the pulses will vary according to the message variations. As the width of the pulses varies, the instantaneous power also going to vary, So in PAM, the bandwidth of the transmission channel depends on the width of the pulse. Yes. In PAM, the amplitude of the pulses is going to be varied. The width of the pulses will remain same. And what is the width of the pulse? That actually decides the bandwidth, कितना channel bandwidth को maintain करना है, that definitely depends on the width of the pulse. If the width of the pulse कम है तो then ज़्यादा bandwidth required होगा and reciprocal to the inverse means it's something like the bandwidth is inversely proportional to the width of the pulse. But it is depends on the width of the pulse. That's true actually. So not correct. Which of the following statements are not correct? 1 and 2 are not correct, so A will be the correct answer. And if you see FDM needs synchronization between transmitter and receiver. This is not correct. Actually, TDM requires synchronization. In FDM, due to slow narrowband fading, this is one of the problems you expected. The fading is one of the problems you experience in the transmission. Only a single channel gets affected. Single channel means इसका ये मतलब है कि single signal. Yes, the total bandwidth allotted for FDM you can see as it is divided into non-overlapping multiple channels, non-overlapping of multiple channels. The total bandwidth is divided as, and this slow narrowband fading, this narrowband fading actually affects the frequency components in a specific channel, frequency components of a specific signal only, specific channel. Yes, that's correct. And if you see wideband fading, this effect of wideband fading will affects all the FDM channels, all the signals which are getting multiplexed will get affected, whereas because of this narrowband fading only one signal is going to be affected. Yes, it is also correct. So which are correct is 2 and 3 will be correct here. So C will be correct answer. and if you see which of the following statements are correct here. So only one bit is used to encode one sample in adaptive delta modulation, that is correct. So in DM and ADM only 1 bit per sample is used, each sample represented by 1 bit. In differential pulse code modulation, the fixed number of levels is used, fixed number of bits or fixed number of levels will be used. Okay, number of levels fixed hai to number of bits also fixed here. So each sample is represented by same number of bits only, fixed number of bits only. Okay, yes, that's correct. In ADM, the quantization, noise and slope overload distortion are present. So this is incorrect actually, will not present. So ADM actually quantization noise here you can understand as the granular noise only. Okay, and slope overload distortion, actually these two errors will be avoided. Okay, so statement 3 is incorrect. So 1 and 2 will be correct. So it is A, it is going to be. This is which of the following statements are correct. This is what I am saying. All the questions are like which of the following statements are correct and incorrect only, surprisingly. Okay. The signal to noise ratio of PCM remains almost constant with compounding. Compounding is one of the techniques. Okay, actually in mains batch, okay, I'm going to discuss about this compounding in PCM. Okay, ESE mains के लिए. Yes, here they will increase S by N of low strength samples का S by N generally कम होगा, but with the help of compounding they will increase the S by N of low strength samples to match with the S by N of high strength samples. So altogether S by N of remains is going to be almost constant over entire dynamic range, is almost going to be constant. N-log to digital converters is not required in delta modulation. This is incorrect because PCM, DPCM, DM, ADM, all these are basically N-log to digital converters only. All this comes under N-log to digital converters only, whereas in delta modulation each sample represented by 1 bit. In that way we will convert a continuous signal to digital. Okay, this is incorrect. So because of variable step size, the dynamic range of adaptive delta modulation is wider than simple delta modulation. That is correct. Okay. So in ADM में if the slope कम है तो over that the slope of the samples slope कम है तो then we will use low step size, and slope ज़्यादा है तो then we will use higher step size. In that way, so this ADM can accommodate very low strength signals to the high strength signals को accommodate कर सकते हैं. So so definitely you can expect the dynamic range that is allowed in ADM will be higher than the normal delta modulation. ADM may, what is the dynamic range of the signal that is allowed, okay, that is definitely higher compared to normal delta modulation. So which of the statements are correct is 1 and 3. So this is B is going to be correct answer. And this is BASK, BPSK, the BFSK. The performance, which of the statements are not correct here? The performance of BFSK in the presence of noise is better compared to that of BASK and BPSK. That is not correct. The noise performance of BPSK is better. The binary PSK systems are more complex than that of binary ASK and binary FSK. Actually, this is a bit of tricky. Yes. And one thing, this is binary ASK. If you say binary ASK supports the data rate up to 1200 bits per second, this is a standard statement kind of question. So binary ASK, this is actually will support the low bit rates को support करते हैं. So in most of the standard telecom systems में BASK supports up to 1200 bits per second only. This is okay. So if which of the following statements are not correct? Not correct means this is so. Not correct means options में 3 नहीं होना चाहिए. आप देख लीजिए options में 3 actually correct here, but 3 is given here. Options में 3 नहीं होना चाहिए. Then definitely A is going to be correct. Okay, and because 3 absolutely is going to be correct. It should not be included in the options. So A is 1 and 2. Actually, BPSK systems are more complex than that of binary ASK and binary FSK. The thing is, in PSK, the demodulation used is synchronous detection, and the synchronous detection definitely coherent detection is only possible. So in that way, it is complex when you compare with non-coherent ASK and non-coherent FSK. Because non-coherent ASK, non-coherent FSK में envelope detection is used. Okay, but if you see ASK and FSK, in that way I can say complex. Okay, PSK is complex compared to non-coherent ASK and non-coherent FSK.
But for ASK and FSK, coherent detection is also possible. So when you compare with coherent detection, coherent ASK and coherent FSK, I can't say that PSK is complex outrightly. I can't give any such conclusion. I can't come to any such conclusion. So this is 2 is going to be not correct. So 1 and 2 are not correct. So I will go with option A. Okay. Yeah. Thank you. All the very best.
ओके सो लेट अस सॉल्व क्वेश्चंस ऑफ सिग्नल एंड सिस्टम। तो वन बाय वन पहले देख लेते हैं। क्वेश्चन क्या है, कंसिडर द फॉलोइंग स्टेटमेंट्स रिगार्डिंग जेड ट्रांसफॉर्म। ठीक है, स्टेटमेंट 1, द आरओसी ऑफ एंटी कॉजल सिग्नल इज इंटीरियर ऑफ अ सर्किल ऑफ सम रेडियस r1। दिस स्टेटमेंट इज करेक्ट। क्यों? क्योंकि इसने क्या बोला कि एंटी कॉजल सिस्टम का आरओसी सर्किल के इनसाइड होता है। ये करेक्ट है। कॉजल का आरओसी सर्किल के आउटसाइड, एंटी कॉजल का आरओसी सर्किल के इनसाइड। स्टेटमेंट इज करेक्ट। स्टेटमेंट 2, इफ x ऑफ n इज एंटी कॉजल देन x ऑफ 0 इज इक्वल टू लिमिट z टेंड्स टू इनफाइनाइट x ऑफ z। दिस स्टेटमेंट इज रॉन्ग। ओके, एक तो ये इनिशियल वैल्यू थ्योरम यूज करने का ट्राई कर रहा है। दिस इज इनिशियल वैल्यू थ्योरम, बट इनिशियल वैल्यू थ्योरम इज एप्लीकेबल ओनली फॉर कॉजल टाइप सिग्नल। तो बेटा ये किस टाइप के सिग्नल के लिए एप्लीकेबल होता है? कॉजल टाइप के सिग्नल के लिए। सो स्टेटमेंट 2 इज रॉन्ग। स्टेटमेंट 3, द आरओसी ऑफ कोरिलेशन ऑफ 2 सीक्वेंसेज, 2 सीक्वेंसेज हैं x1n एंड x2n, इन दोनों का आरओसी, इन दोनों के कोरिलेशन का आरओसी इज एट लीस्ट द इंटरसेक्शन ऑफ द आरओसी ऑफ x1z एंड x2z इनवर्स। ये करेक्ट है क्योंकि इसमें बोला r x1 x2 r x1 x2 l। अगर ये कैलकुलेट करना है तो ये ऐसे कैलकुलेट होता है x1 l कन्वोल्यूशन विथ x2 ऑफ माइनस l। अगर आप कोरिलेशन करते हैं तो ये कन्वोल्यूशन के हेल्प से कैलकुलेट हो जाता है। सेकेंड फंक्शन को फोल्ड करें, फर्स्ट के साथ कन्वॉल्व करें। अब अगर आप इस पर z ट्रांसफॉर्म अप्लाई करेंगे तो राइट साइड में क्या होगा? दोनों का z ट्रांसफॉर्म मल्टीप्लाई होगा। x1l का ट्रांसफॉर्म x1z, x2l का ट्रांसफॉर्म x2z इनवर्स। टाइम डोमेन में कन्वोल्यूशन, तो z ट्रांसफॉर्म में क्या? मल्टीप्लिकेशन। अब आप जो भी आरओसी लिखेंगे वो इस टर्म से रिलेटेड लिखेंगे, मतलब x1z इंटू x2z इनवर्स का आरओसी लिखना पड़ेगा। और वही इसने बोला है, x1z और x2z इनवर्स के आरओसी, इन दोनों के इंटरसेक्शन से जो आरओसी मिलेगा वो रिजल्टेंट आरओसी होगा। सो दिस स्टेटमेंट इज करेक्ट। तो करेक्ट स्टेटमेंट्स आर 1 and 3। 1 and 3 मतलब कौन सा ऑप्शन करेक्ट है? ऑप्शन बी। नेक्स्ट क्वेश्चन, कंसिडर द फॉलोइंग स्टेटमेंट्स रिगार्डिंग FIR फिल्टर। FIR का मतलब क्या होता है बेटा? फाइनाइट इम्पल्स रिस्पॉन्स फिल्टर। स्टेटमेंट 1, FIR filters are sometimes called moving average filter। स्टेटमेंट 1 इज करेक्ट क्योंकि मूविंग एवरेज फिल्टर को हम लोग FIR फिल्टर से रियलाइज कर सकते हैं। ऐसे भी जो मूविंग एवरेज फिल्टर्स हैं इसमें ऑल जीरोज फिल्टर्स होते हैं एंड ऑल जीरोज फिल्टर्स आर ऑल्सो नोन एज FIR फिल्टर्स। ठीक है। स्टेटमेंट 2, बिकॉज ऑफ द लीनियर फेज रिक्वायरमेंट द जीरोज ऑफ द ट्रांसफर फंक्शन मस्ट लाई इनसाइड द यूनिट सर्किल इन द जेड प्लेन। अब इसने बोला है कि FIR फिल्टर में जो जीरोज होते हैं वो सारे जीरो यूनिट सर्किल के इनसाइड लाई करेंगे। दिस स्टेटमेंट इज रॉन्ग। क्यों? क्योंकि इसने क्या लिखा? लीनियर फेज FIR फिल्टर। ओवरऑल फिल्टर कैसा? लीनियर फेज FIR फिल्टर। लीनियर फेज FIR फिल्टर में ऐसा रिलेशनशिप होता है, सपोज 2 जीरोज हैं, देन रिलेशनशिप विल बी Z2 इक्वल टू 1/Z1। ठीक है। मतलब जीरोज आर रेसिप्रोकल टू ईच अदर, किसमें? लीनियर फेज एफआईआर फिल्टर में। अब आप खुद बताओ, अगर एक जीरो यूनिट सर्किल के इनसाइड है तो दूसरा जीरो किधर होगा? यूनिट सर्किल के आउटसाइड, क्योंकि इनमें इनवर्स रिलेशनशिप है, Z2 इक्वल टू 1/Z1। सो स्टेटमेंट 2 इज रॉन्ग। ठीक है। स्टेटमेंट 3, द लीनियर फेज कैरेक्टरिस्टिक मेक्स द टाइम डिले ऑफ द फिल्टर इक्वल टू हाफ इट्स लेंथ विच में बी लार्ज। ये स्टेटमेंट करेक्ट है। लीनियर फेज एफआईआर फिल्टर में डायरेक्ट फॉर्म लीनियर फेज एफआईआर फिल्टर होता है, जिसमें नंबर ऑफ डिले एलिमेंट्स, नंबर ऑफ मल्टीप्लायर्स, नंबर ऑफ एडर्स अप्रॉक्सीमेटली हाफ हो जाते हैं, और जो ब्लॉक डायग्राम की कॉम्प्लिकेसी है वो भी अप्रॉक्सीमेटली हाफ हो जाती है। तो स्टेटमेंट 3 क्या है? करेक्ट। 1 and 3 आर करेक्ट, सो आंसर इज ऑप्शन बी। नेक्स्ट क्वेश्चन, द Z ट्रांसफॉर्म ऑफ माइनस ए की पावर एन यू ऑफ माइनस एन माइनस वन स्टैंडर्ड सिग्नल है। इसका Z ट्रांसफॉर्म लिखते हैं 1/1 माइनस ए जेड इनवर्स विथ आर ओ सी इनसाइड सर्किल मॉड Z लेस देन मॉड ए। अब आप इस 4 ऑप्शंस को अगर चेक करेंगे तो ऑप्शन ए काफ़ी हद तक नियर है, बट इसमें करेक्शन की रिक्वायरमेंट है। दिस क्वेश्चन विल नीड सम करेक्शन। करेक्शन क्या है? यहाँ ये माइनस साइन नहीं होना चाहिए, क्योंकि ये जो ऑप्शन डी है या फिर ऑप्शन सी है ये तो कभी भी मैच नहीं होने वाला है। आप अगर इस ट्रांसफॉर्म को या ऑप्शन डी के ट्रांसफॉर्म को कंपेयर करें तो इससे मैच नहीं होगा। तो एक ही पॉसिबिलिटी है। देखिए ऑप्शन बी तो हो नहीं सकता और उसी सर्किल के आउटसाइड है, तो ये नहीं, तो ऑप्शन ए ही आंसर है। बट इसमें करेक्शन की रिक्वायरमेंट है, यहाँ माइनस साइन नहीं होगा। ठीक है। नेक्स्ट क्वेश्चन पर चलते हैं। द इनवर्स Z ट्रांसफॉर्म ऑफ x ऑफ Z इक्वल टू log 1 प्लस ए जेड इनवर्स विथ आर ओ सी मॉड Z ग्रेटर देन मॉड ए। इसके लिए क्या होगा? बेटा जब भी Z ट्रांसफॉर्म या लैप्लास ट्रांसफॉर्म लॉगरिथम में होता है तो डिफरेंशिएशन इन फ्रीक्वेंसी डोमेन प्रॉपर्टी को यूज़ करते हैं। तो आपको प्रॉपर्टी कौन सा यूज़ करना है? डिफरेंशिएशन इन फ्रीक्वेंसी। प्रॉपर्टी में क्या होता है? फॉर एन इंटू एक्स ऑफ एन ट्रांसफॉर्म इज व्हाट? माइनस जेड डी एक्स जेड अपॉन डी जेड। तो आप क्या लिखते हैं? माइनस जेड। अब आप अगर इसको डिफरेंशिएट करेंगे इसे तो 1/1 प्लस ए जेड इनवर्स। अब 1 प्लस ए जेड इनवर्स को जेड के आगे डिफरेंशिएट करोगे तो क्या लिखोगे? माइनस ए जेड की पावर -2। RHS को रीअरेंज करोगे तो आप क्या लिखोगे? थोड़ा एक बार अच्छे से देखो, क्या लिखोगे? आप इसे लिखेंगे क्योंकि यहाँ माइनस से माइनस कैंसिल आउट होगा, जेड से जेड इनवर्स कैंसिल आउट होगा, तो बेटा आप क्या लिखते? ए जेड इनवर्स अपॉन 1 प्लस ए जेड इनवर्स, ऐसा लिखते ना। ठीक है। ROC क्या है? मॉड जेड ग्रेटर दैन मॉड ए। अब यहाँ RHS का इन्वर्स लो, फिर LHS से कंपेयर करो। तो जब आप RHS का इन्वर्स लेंगे तो RHS का इन्वर्स कुछ ऐसा आने वाला है, माइनस 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 ए की पावर n-1 u ऑफ n-1। ठीक है। इंटू क्या? इंटू ए, इंटू ये भी आएगा। फाइनली जब आप इसको अरेंज करेंगे x ऑफ n को तो इनमें से किस ऑप्शन से मैच होगा? ये ऑप्शन डी से मैच होने वाला है। ओके। एक बार इसको कंफर्म कर ले। देखो u ऑफ n-1 है, मतलब n ग्रेटर देन इक्वल टू 1 होना चाहिए। अब यहाँ पर भी है और यहाँ पर भी है, मतलब इन दोनों में से कोई एक आंसर है। फिर आपने इसमें भी थोड़ा ऑब्जर्व किया तो -1 की पावर n नहीं आएगा, क्योंकि यहाँ -1 की पावर n-1 साफ साफ दिख रहा है। आप अच्छे से देखो, -a की पावर n-1 है ना, तो इसे दो पार्ट में लिखते हैं, -1 की पावर n-1 इंटू ए की पावर n-1, और -1 की पावर n-1 ये तो नहीं होगा। हम -1 की पावर n+1 हो सकता है, क्योंकि आप -1 की पावर n-1 को -1 स्क्वायर से मल्टीप्लाई कर सकते हो, क्योंकि -1 स्क्वायर +1 होता है। ठीक है। तो आप इसको a की पावर n-1 लिख सकते हैं, a की पावर n, क्योंकि यहाँ पर a है, यहाँ a की पावर n-1, सो a की पावर n, फिर -1 की पावर n-1 इंटू -1 के स्क्वायर से मल्टीप्लाई कर दो, क्योंकि -1 की स्क्वायर 1 होता है। फिर कंपेयर करो तो किससे मैच होगा? ऑप्शन डी से मैच हो जाएगा। आगे बढ़ते हैं। कंसिडर द फॉलोइंग स्टेटमेंट्स रिगार्डिंग यूनिट इम्पल्स सिग्नल। स्टेटमेंट 1 क्या है? द डिस्क्रीट टाइम यूनिट इम्पल्स इज द फर्स्ट डिफरेंस ऑफ डिस्क्रीट टाइम स्टेप सिग्नल। सो दिस स्टेटमेंट इज करेक्ट, क्योंकि इसने बोला डेल्टा n इज इक्वल टू un माइनस u ऑफ n-1। करेक्ट तो है। स्टेटमेंट 2 देखते हैं, द एम्पलीट्यूड ऑफ यूनिट इम्पल्स सिग्नल इज इक्वल टू 1 एट n इक्वल टू 1, दिस स्टेटमेंट इज रॉन्ग। तो इसने बोला डेल्टा n कौन, डेल्टा n इक्वल टू 1 पर 1 होगा, जो कि रॉन्ग है, n इक्वल टू 1 पर 0 होता है। Statement 3. The continuous time unit impulse can be obtained as first derivative of continuous time unit step. This statement is correct, क्योंकि इसने बोला डेल्टा टी इज इक्वल टू, क्या बोला, डेरिवेटिव ऑफ यू टी, तो ये तो करेक्ट है ना बेटा। इम्पल्स स्टेप का क्या होता है, डेरिवेटिव होता है, करेक्ट है। 1 and 3 आर करेक्ट, ऑप्शन बी इज करेक्ट। आगे बढ़ते हैं, नेक्स्ट क्वेश्चन, कंसिडर द फॉलोइंग स्टेटमेंट्स रिगार्डिंग सिस्टम प्रॉपर्टीज। Statement 1. A system is a causal if the output at any time instant depends on values of the input at only, input की values पर depend करता है at only the present and past times. Such a system is often referred as being non-anticipative. ओके करेक्ट है, क्योंकि कॉजल सिस्टम में आउटपुट इनपुट के फ्यूचर वैल्यू से इंडिपेंडेंट होता है, तो किस पे डिपेंड करेगा, प्रेजेंट और पास्ट पर, यही इसने बोला है, करेक्ट है, ठीक है। और कॉजल सिस्टम को नॉन एंटीसिपेटिव भी बोलते हैं। स्टेटमेंट 2, समर इज एन एग्जाम्पल ऑफ ए डिस्क्रीट टाइम सिस्टम विथ मेमोरी, करेक्ट आंसर है। व्हाट इज समर, समर इज yn इक्वल टू समेशन x ऑफ k रेंज ऑफ k माइनस इन्फानाइट टू n। इस सिस्टम को क्या बोलते हैं, समर बोलते हैं या फिर एक्यूमुलेटर। इसमें डिपेंडेंसी किस पर है, प्रेजेंट और पास्ट पर, और अगर पास्ट पे डिपेंडेंसी है तो मेमोरी सिस्टम तो होगा ही, क्योंकि स्टैटिक या मेमोरीलेस होने के लिए बस केवल प्रेजेंट पे डिपेंडेंसी होनी चाहिए थी, यहाँ पास्ट पे भी डिपेंडेंसी है, इसलिए स्टेटमेंट 2 करेक्ट है। स्टेटमेंट 3, अ सिस्टम इज सेड टू बी मेमोरीलेस, इसने क्या बोला, मेमोरीलेस इफ इट्स आउटपुट फॉर ईच वैल्यू of independent variable at a given time is dependent on the input at only the same time instant. तो इसने इनपुट को कैसा इनपुट बोला, प्रेजेंट इनपुट। तो इसने बोला कि एक ऐसा सिस्टम जिसमें आउटपुट बस केवल इनपुट के प्रेजेंट वैल्यू पर डिपेंडेंट है, तो स्टैटिक होगा या मेमोरी होगा, मेमोरी लेस होगा, करेक्ट है, क्योंकि मेमोरी लेस सिस्टम को स्टैटिक सिस्टम भी कहते हैं। स्टेटमेंट 3 इज ऑल्सो करेक्ट। तो 1, 2 and 3 आर करेक्ट, तो आंसर कौन सा ऑप्शन है, ऑप्शन डी, ठीक है। नेक्स्ट क्वेश्चन की ओर चलते हैं, कंसिडर द फॉलोइंग स्टेटमेंट्स रिगार्डिंग लैप्लास ट्रांसफॉर्म। द ROC ऑफ x ऑफ s कंसिस्ट ऑफ स्ट्रिप्स पैरेलल टू द j ओमेगा एक्सिस इन द s प्लेन, करेक्ट है। आप जब भी ROC लिखते हैं एस प्लेन में तो इसमें पैरेलल बैरियर्स आते हैं, जिसको आप स्ट्रिप भी कह सकते हैं। तो स्टेटमेंट 1 क्या है, करेक्ट है, ओके। फिर इसके बाद स्टेटमेंट 2, फॉर रैशनल लैप्लास ट्रांसफॉर्म द ROC डज नॉट कंटेन एनी पोल्स, ये तो करेक्ट है। ROC में क्या इंक्लूड नहीं होता है, पोल इंक्लूड नहीं होता है, क्योंकि पोल पर ट्रांसफॉर्म इनफाइनाइट होता है, तो ROC में पोल इंक्लूड नहीं होता है, स्टेटमेंट 2 करेक्ट है। इफ xt इज ऑफ finite duration and is absolutely integrable, then ROC is the entire S plane. So this statement is correct. इसने बोला कि अगर कोई finite duration का सिग्नल है, नेचर कैसा है, absolutely integrable, तो ROC entire S plane होगा, this statement is correct. आपने अगर ओपेनहेम की किताब पढ़ी होगी तो ओपेनहेम में जो लैप्लास का टॉपिक है उसमें जो ROC के प्रॉपर्टीज़ है, बेटा जा करके पढ़ लेना, प्रॉपर्टी 1, प्रॉपर्टी 2, प्रॉपर्टी 3 यही है। तो आपके नॉलेज के लिए मैंने बता दिया है कि ये रेफरेंस कहाँ से लिया गया है, ओपेनहेम की किताब से लिया गया है। 1, 2 and 3 आर करेक्ट, ऑप्शन डी इज करेक्ट, ठीक है। चलिए, हमने सिग्नल के सारे क्वेश्चंस कंप्लीट कर लिए हैं। अब इसके बाद नेक्स्ट सब्जेक्ट आएगा, तो नेक्स्ट सब्जेक्ट के लिए थोड़ा वेट कर लीजिएगा, ओके प्लीज़ थोड़ा देर वेट करिए, नेक्स्ट सब्जेक्ट अभी स्टार्ट करेंगे।
Yeah, good evening students. See in the questions of advanced communication systems from the ESE paper. So consider a multimode step index fiber that has core radius of 25 micrometers. So A is given, A value is equal to 25 micrometers, and next one is given refractive index N1, N1 is equal to 1.48, and refractive difference, relative refractive index difference is given 0.01, lambda operating wavelength is given, so 840 nanometers. Asking for the normalized frequency, formula is equal to 2 pi a by lambda into N1 into root of 2 delta. Substituting these values, so we are getting the answer is equal to 39, that is option A. So all the given values we substitute here and you get the value is equal to 39. So coming to the next question. So it's all about the satellite communication question is given. So perigee is the one which is called as the nearest distance, obviously we knows that. Apogee is the farthest distance, and eccentricity is the center of the ellipse we are having. So first perigee, for P we can check it. So it is the point on the satellite orbit that is the farthest distance from the center of the earth, but not the farthest, which is going to be the smallest. Perigee is the smallest one. So it is the point on the orbit that is nearest to the center of the earth. So nearest to the center of the earth is present here, center of the earth. So P is equal to 1. So option which is going to be satisfying is equal to B. See, only P is equal to 1 is present. Remaining no need to check it also. Okay, the value of P is going to be equal to 1. So that's option B is the correct answer. So now coming to the next question, that is another question, earth station. So this is also for satellite communication system. Earth station antenna has a maximum gain of 60 dB. So gain is given. So gain G is equal to 60 dB is given. At the operational frequency is fed from the power amplifier generating 10 kilowatts. So power P is equal to 10 kilowatts. We can tell it as PT also, the transmitting power. So feeder loss, so LF is going to be equal to 2 dB. Feeder loss is given. Asking ARP. So asking ARP, check the options. ARP required in terms of dB. So ARP in terms of dB means obviously we knows that is going to be equal to that of PT in terms of dB plus the value of gain GT in terms of dB minus LF, the feeder loss we are having is said to be called as the LF. So feeder loss is present in terms of dB. So in terms of dB we are having. So if you talk about that EIRP, we can tell like this, that is equal to 10 into log of, the value is equal to 10 to the power of 4 of base 10, because 10 kilowatts is equal to 10 power 4 watts is the value we are having. So plus gain is given, it is already given in terms of 60 dB, and feeder loss is equal to 2 dB. Just to do the calculation, we get the EIRP in terms of dB. The EIRP in terms of dB, the value is going to be equal to that of 98 dB. So 98 dB in the sense means option A is the correct answer we are having. Okay, because this become 40 dB, 60 plus 40, 100, 100 minus 2. Hope you understand it. Right. So that's about the satellite communication question. So coming to the next question. Right. So it's about the optical communication. So optical communication systems. So consider the following statements related to the optical fiber. First one is multimode step index fiber is given. So multimode step index fibers are ideally suited for high bandwidth and very long haul applications. See, if modes are going to be high for long distance, dispersion increases, then automatically what happens is the losses increases. That's why multimode fibers can't be used for long distances. Similarly, if you come for the second statement, single mode fiber, the dispersion is very less, we can use for the long distance. But the reason it is given is using for your lower bandwidth and shorter distances it was given. That means both are going to be the wrong. They must be ulta. Single mode and multi-mode must be reverse and it will be correct. So neither 1 nor 2 will be the correct. Okay. So next one. Coming to the next one, that is all about the 82nd question. If you see this question, so virtual circuit packet switching, and next important thing is that is datagram packet switching and circuit switching. See, circuit switching in the sense means the route must be going to be established. The route is established for this path. Okay. So once we talk about this one, so circuit switching is going to be having the fixed bat and data is going to be having the route established for each packet. So virtual circuit packet switching is no dedicated path. So if you see the options carefully, that means if you are talking about the options carefully, so we are going to be getting the option is equal to C, because the P is equal to 1, no dedicated path will happens, and Q is equal to 3, route established for each packet, circuit switching is having a fixed bandwidth is present. So this is the question that we are having. So next question, if you talk about the next question, consider the following statements related to CDMA. So the above statements is our correct is gain. So for CDMA, because of SPED spectrum is obtained by the use of noise like signals, where each user has a unique code. Unique code is the specialty of CDMA, code division, unique code, and privacy is inherent. Because of the unique code, the privacy is inherent, security is very, very high. So statement was going to be the correct one we are having. So statement 1 is the correct statement we are having. So the signals closer to the receiver are received with less attenuation than the signals further away. That's very clear. Near far problem we studied in our CDMA. So that tells very clearly such that both 1 and 2 are correct. That means for this question, so asking about the correct statement, so both 1 and 2 are correct. Option C is the correct answer. So next, coming to the another question. So in this question he was going to be giving you the prime number P is equal to 47, G is equal to 3 is given, and we have two users are there, A and B. So A picks a random number x is equal to 8 and B picks a random number y is equal to 10. So what are the secret case he was asking? The security question in data communication. So secret case, security question in data communication for Delphi-Hellman key exchange algorithm. So I want to tell you such that first of all generates the public keys. First step is generate the public key. So when you are going to be generating the public key was going to be generated for the your party A and for the party B, because of the two parties are there, A and B we are having. Okay. So first of all we are going to generating a public key. So for party A we are going to be generating the public key. So A of public, that is called as the public key. The public key we are going to be having is g to the power of x, g to the power of x into mod of the value is equal to p. P is the prime number, or the prime number we are taking. P is the prime number, and that prime number is going to be equal to 47 we are having. Now just try to understand this one. So we are talking about the public key. This value is equal to g. G is already given in the question, that is equal to 3 to the power of x. X was going to be taking the value is equal to 8. Then that value was going to become equal to 3 to the power of 8. So into mod of 47. So this value, by using the calculator, a continuous division, remainder will going to be taken. That value of is equal to 28 we are getting. So similarly I am going to be calculating for party B also, because I am calculating the public key. So party B. So when you are talking about the party B, that is equal to B of public key is going to be equal to g to the power of y. So value is equal to that of mod of P is present. So this value is equal to g. G is already given 3 and y takes the number called as 10. So mod of value is equal to 47. This value by calculating the part B. So B of public is going to be equal to 17 we are getting. So this is what we calculate the public key for both the two parties, party A and party B. So after public key is going to be calculated, so we have to calculate the private key of the two parties. So private key was going to be taken. So when you are talking about the private key, because that is was asking in the question, the secret key, private key is nothing but a secret key we are having. So private key for party A, so for party A, that is equal to Ka. When you talk about the Ka, so Ka was going to be equal to that of the both will be exchange. Actually for Ka, what we are taking is equal to the for B, and for B we are going to be taking the A, that is going to be represented like this. So this value was going to be equal to that of B public of x of mod value is equal to P. That is for the Delphi-Hellman algorithm we are having. Then Ka is equal to, if you are talking about the B public value, how much you are getting, that is 17. 17 to the power of x, x value is equal to 8. Mod of the prime number is equal to 47 we are having. So that gives the Ka value, that gives the Ka value. So that Ka value we are getting equal to that of 4 we are getting, that Ka value we are getting is equal to 4. So that is equal to 4. So next for party B, we can talk about the party B, and this is the private key is not set to be the secret key we are having. For party B, KB we are having. So KB is equal to that of A public key, the public key of A is sharing with respect to the taken value of Y into mod of the prime number, the mod of the prime number is equal to P, and A of public key is obtained the value is equal to 28, 28 whole to the power of 10, the value is equal to mod of the 47 we are having. So mod of 47, and that KB is also going to be equal to 4. Both K and KB are having identical keys are obtained, and such identical keys are going to obtain as option A. So option A is the correct answer we are having. This is the procedure for finding the Diffie-Hellman algorithm. So this also takes more time because of the calculation of mod 47 and this to the power of 8 values. It will take more amount of time actually, right? The question is asked in the ESE. Next one. See that a host is connected to 16 synchronous terminals through a pair of statistical, and this one is a small mistake is there, it is also asynchronous, 16 asynchronous terminals through a pair of statistical time division multiplexers. So utilizing the bitmap multiplexing, so using TDM, using a bitmap multiplexing. So the 16 synchronous terminal ports operate at 1200 bps, at 1200 bps they are operating. The line port has a bit rate, RB is given. So from the given question we get RB is going to be equal to that of 9600 bits per second, and the number of sessions is equal to 16, already it is given 16, host is connected to 16 terminals are there, capital N is equal to 16. Asking what is the maximum line utilization efficiency, which is said to be called as the E value, which is called as maximum line utilization efficiency, we are having utilization efficiency. And if you see the protocol using is HDLC, the HDLC is going to be having the header with 7 fields are going to be present, that we study in our classroom in data communication. If you talk about the efficiency of this was going to be equal to that of E. So E is equal to that of n divided by n plus 7 is the value. So why we are adding the 7 means HDLC fields we are having is 7, that is added. So n divided by n plus 7, so n is equal to 16, so 16 divided by 16 plus 7. So this gives the efficiency that value, what are the value we are having? So that value was going to be equal to that of 0.696 will be obtained. Next asking the throughput is nothing but if you see the throughput is going to be equal to that of maximum line utilization into bit rate, the bit rate is equal to RP. So maximum line utilization what you are getting is equal to that of 0.696 into RB. The bit rate is equal to 9600 bps. The resultant value what you are getting is equal to 6678 bps is the value. So this value is equal to the option C is the correct answer. Okay. So that's about the question number 86. So that's about the question number 86 we are having. So the another one that I want to tell to you is next question. So CSMA code, CSMA stands for, you are asking. So it is called carrier sense multiple axis. CSMA, carrier sense multiple axis. In CSMA we are going to be having two things. One is called CSMA by CA and CSMA by CD, collision avoidance and collision detection. Okay. So we are having two things. One is called as CSMA by CD, collision detection. Next one is called as CSMA by CA, collision avoidance. So carrier sense multiple axis. When more than one stations are going to be using the same carrier, they can sense it and they can use it. Okay. So next question. So the attenuation in optical communication system is usually expressed in decibels per unit length, as he was asking. Once again, optical communication system. So this is what it is given in the question. So attenuation alpha in terms of dB is equal to 10 into log of base 10 of P in by P out we are having. By P in by P out, and which was going to said to be called as the loss. So attenuation in optical fiber taking the loss directly, P in by P out. So P in by P out in the sense means which is given as option A is the correct answer. Okay. So next one, come to the next question. So IP layer, if you talk about the IP layer, which is called internet protocol layer, you just observe one thing carefully. Physical layer was going to use the transmission of bits, so S is equal to 1. So physical layer is for transmission of bits. So IP layer, internet protocol layer. TCP by IP, TCP by IP or UDP layer. If you see TCP by IP or UDP layer, that comes under the transport layer of the OSI reference model. That means Q is equal to 3. If you talk about the option Q is equal to 3, in between these two, A and B, answer will be present. In between A and B, the answer will be present, and that answer will going to be considered between the A and B. So if you talk about the A and B, answer is present. So in between these two, so two things are completed. TCP by IP. TCP by IP is the application layer, IP layer, network layer of the OSI reference model. So network layer of the OSI reference model. So P is equal to 2. So P is equal to 2. P is equal to 2. Q is equal to 3. Q is equal to 3. R is equal to leftover option is this only. So I am going to be using this option also. The leftover option is this option only. So S is equal to physical layer. So option A is the correct answer. So these are the questions we are having. So covered all the areas in data communication system. Okay. So thank you.
Friends, let us now take up the questions on the advanced electronics. The first question happens to be twin tub CMOS. We have done in the class twin tub CMOS. Okay. So it clearly says N-well CMOS are superior compared to P-well CMOS. Of course, yes. Okay. The obviously. Okay. So because when you say N-well CMOS, they are basically the PMOS, and P-well CMOS is NMOS. Okay. So the first statement is correct. Next, latch up can be reduced. Already we have discussed. Latch up is basically an unwanted condition between the power supply and ground because of the parasitic BJT formations. So that can be avoided by creating a low resistance path to ground. Yes. Okay, that is also correct. Next, the twin tub CMOS fabrication is to separate optimization of NNP transistors. That is also correct. So the option for this question is basically 1, 2, 3. Okay. Simple question basically on the CMOS fabrication steps. Let's come to the next question. Which of the following has a statements is correct? Bipolar technology having delayed sensitivity. See, delay means RC. Whenever they say RC, okay, bipolar technologies are having RC delay. Okay, delay sensitivity to the load. That means if load changes, load capacitance changes, so the bipolar technologies have higher sensitivity. Wrong. Basically, the bipolar transistors can actually have a more driving capability. They have a higher driving capability. They can drive more current. Okay, so there is no problem. Even though the load changes, load capacitance changes here, bipolar transistors can easily drive it. Okay, there is no problem. Okay, next, so this statement is wrong. Second statement, CMOS technologies are having low drive current as compared to bipolar. Correct. Okay, CMOS has lesser driving current compared to the BJT. Next, CMOS technologies are low power. Obviously, we know this. CMOS is basically low power. So the answer for this question is 2 and 3 only. Okay, right. Simple question, understood. Simple question. The only thing students may not understand is drive sensitivity. Sorry, high delay sensitivity. Delay sensitivity is RC. So delay means R into C. So load means load capacitance. That means C is changing. If C is changing, what will happen? Okay. So is the bipolar junction transistor sensitive? No. Even though capacitance changing, no problem, because bipolar junction transistor has a higher capability to drive more current. So it can obviously drive more current and charge up the capacitor faster. So that's the point. Okay. Right.
Now, now this is which one of the following approaches is used to reduce the area per bit required? Basically consists of capacitor. Okay, in a memory where we use capacitor, DRAM. Okay, it's a simple DRAM cell. Okay, so DRAM cell basically uses one transistor and one MOS capacitor. Okay, so DRAM cell basically uses one transistor and one MOS capacitor. He's clearly telling you are using a to bit storage. So capacitor which can be charged during the write from read write line, provided the row select line is high, obviously. So you can use one transistor. Okay, so basically actually it's one transistor plus one capacitor. Okay, frankly speaking it's one transistor plus one capacitor. Frankly speaking, slightly ambiguity is there in this question, slight ambiguity, because the students may think that the capacitor is not given, so they will select 2, but I would recommend the correct answer is one transistor plus one capacitor, because already he is saying capacitor here. Okay, so the appropriate option is option A. Okay, now let's see this simple question on the pipelining. Which one of the following technique is used for decomposing a sequential process? You are having a big process, we decompose into smaller parts. Okay, so sub operations, see, we are decomposing into sub operations, with each sub operation being executed in a specific dedicated hardware. Pipelining, simply remember, okay, suppose you have a 2-stage pipeline. Okay, so when instruction 1 is executed here, I2 will be executed here. Simple 2-stage pipeline, you remember, you have done this. Okay, when instruction I1 gets executed here, I2 will get executed here. So you can one instruction is divided into 2 parts, and those parts are basically executed here at the same time. So it's basically simple pipeline processor. Okay, simple question on the pipeline. Next. Okay, now which type of procedure is employed where some computers give the responsibility of solving the data conflict? Okay, so where the compiler does the high level compiler that translates into high level programming language into machine language. So basically if you see hardware interlock, operand forwarding, branch target buffer, these 3 are the hardware techniques. Okay, these 3 are the hardware techniques. Okay, these 3 are the hardware techniques. The only software technique is delayed load. So compiler is basically software. Okay, so compiler can only control the entire system by using delayed load. Okay, so these 3 happens to be hardware techniques. So the appropriate answer for this question is delayed load. Okay, that's it from advanced electronics. It's very simple topic. Thank you.
Hello students, hi everyone, I hope you all done well. Right, so here we are going to discuss questions from the subject computer organization and architecture. Right, first question from this subject is the interrupts such as register overflow, divide by 0, invalid operation, stack overflow and protection violation are classified as. This is the question. Okay, these interrupts comes under which category? Right, directly here answer is the internal interrupt. Okay, internal interrupt is a signal which is generated by the hardware present in the motherboard. Okay, so whatever the hardware embedded in the processor chip, so that hardware generated signals are called as the internal interrupt signals. So these all are the interrupts which are coming under the internal category. So answer is B. Next question, which of the following statements are correct with respect to CISC computer? As you know the characteristics of a CISC processor, right? CISC processor contain less number of registers, more number of addressing modes. Okay, so that operations are directly processed on a memory content as well as the registers. So here instructions are designed with the register and memory addressing modes combinations, not only from register. So less number of registers are there, more number of addressing modes present. Okay, next, variable length instructions. Okay, so you know all other characteristics which are related to the CISC processor. So once you remember the characteristics, then you can able to select the right answer. The first one is it provides direct manipulation of operands residing in the memory. Yes, this statement is true because CISC processor contain the less number of registers, so that instructions are designed with a combination of register and memory addressing modes. So A is true. It has instructions that use only processor registers. It has instruction that uses only processor registers. This statement is wrong because CISC processor contain the less number of registers. So we have a instructions with a combination of register and memory. Okay, not only the register related instructions. Next, if more instructions and addressing modes are incorporated, more instructions, more addressing modes into a computer, more hardware logic is needed to implement and support them, and this may cause the computations to slow down. Obviously, when system contain the more number of instructions, okay, more number of addressing modes, okay, there is a need of the additional hardware. So due to that kind of implementation, okay, execution time of the program will be increased. So when we fetch the data always from the memory, okay, machine cycles are counted, so that time will be increased. When time increases, performance decreases. So this statement is also true. Okay, right. Select the correct answers using the codes given below. So here these three options may which is right. So first statement is right, third statement is right. So answer is D. So here third statement repeated here. So answer is D. 1 and 3. These two characteristics are true in the CISC computers. Okay, students. Next, in a 64 word stack, okay, stack pointer contain how many bits? You know that stack pointer holds the top of stack address. Stack pointer holds the top of stack address. Here stack size is already given. So stack is equal to 64 words. So what it means? We have a 64 cells. In every cell we have a one word space like this, 0, 1 and so on 63. So to address this stack, how many bits of address required? That is log 64 base 2. This is equal to 6-bit address. Okay, 6-bit address required. Right? So stack address is pointed by the stack pointer. So the stack pointer size equal to 6 bits. So answer is A. Stack pointer holds the top of stack address. Yaha 64 word stack, that's what, to address a 64, 6 bits is sufficient. Answer is A. Okay, students. All right. Yeah, coming to the next question. This question is the infix to postfix notation. So here there is a simple arithmetic expression given. This is the expression. Okay, then what is the expression written in the reverse Polish notation? Reverse Polish notation is the notation or is the way to represent the statement without brackets. So here brackets are there. So we should write that same sentence without brackets. By removing the brackets, we should write it. Okay, so this reverse Polish notation is called as the postfix notation. postfix notation means operator comes after the operands. Operator comes after the operands. For example, if I have a x into y, okay, so iska postfix notation is xy, after that operand coming. So this is the postfix notation. So now here we should remove the brackets from inside to outside, right? So first remove bracket of a plus b, so that is ab plus, and coming to this inside to outside, this is the first inside bracket is remove bracket of d plus e. So d plus e, that is de plus. Next, here left to right, so now here evaluate c into d plus e. So here d e plus, okay, c into d plus e. So here d e plus c star, correct? Then next evaluate c into d plus e plus f, correct? So here d e plus c star f plus, correct? So now next is evaluate the total thing. Now evaluate a plus b into c into d plus e plus f, इसको evaluate करना, correct? So what is that? A b plus, right, d e plus c into f plus into, right? So this is the expression. First ab plus, then iska evaluation is de plus c into f plus, then this operator comes after the operands. So this is the reverse Polish notation of the given expression. Actually this is implemented in the system by using the stack, okay. Reverse Polish notation is nothing but a postfix notation, okay. Operator comes after the operands, so removing the brackets from inside to outside, okay, starts from the left side to right side. That's what first we evaluated a plus b, ab plus. Next evaluate this side inner bracket d plus e, after that c into d plus e, after that c into d plus e plus f, after that multiplication, okay students. So this is the answer. So go to the options, select the right answer. So right answer selection is C. C is matching AB plus DE plus C into F plus star. Yes, answer is C. C is matching. Okay students, all right. Next, in which of the following addressing modes effective address is equal to address part of the instruction? Okay, so that means if you take the instruction design, there is a opcode and a address. So in this address field of instruction contain the effective address. Address field contain effective address. So which addressing mode is coming under this? Implied means opcode itself contain the operand's information. Direct addressing mode means address field contain the effective address. Immediate means address field contain the data. Register indirect means address field contain the address of effective address. So what they are saying? Address field contain effective address. In which mode it is matching? Answer is B. Direct addressing mode. In the direct addressing mode, address field of instruction contain the effective address. Okay students, that's it from the computer organization and architecture. Thank you.
Yeah, okay. Good evening students. Yeah, welcome to measurements. Yeah, in ECE I think more questions came. Okay, fine. Yeah, the first question, consider the following statements regarding dynamic characteristics of a measurement system. Right. What is this dynamic characteristics? This is changing with respect to time. Okay. Yeah, what they are asking here, in retardation type measuring lag, the response of the measurement system begin after a dead time. What is the exact meaning of dead time? Dead time means the time taken by the instrument, to give some response, right. This is called transportation lag, it is a time lag, dead time related to time lag. Okay. Right. So what they are asking, which of the following statements are correct? It is not a retardation lag, it is not a retardation type lag. So statement number 1 may not be correct. Okay, fine. Yeah, fidelity. What is the meaning of fidelity? Fidelity refers to loyalty. Fidelity refers to loyalty. Fidelity is defined as the degree to which measurement system indicates changes in the measured quantity without any dynamic error. That means there is no change with respect to time. There is no change with respect to time. Correct statement. Measurement error is the difference between right, the true value of the quantity changing with respect to time and the value indicated by the measurement system. If there is no static error is assumed. I think it is exactly correct. So statement number 2 and 3 correct. Okay. Yeah, the minimum and maximum ranges of a temperature tungsten resistance RTD. It is instead of thermocouple, this is RTD only. Generally tungsten RTD we are going to use. Okay. This tungsten RTD, right, this is the range in general, typical value minus 200 degree centigrade to 1000 degree centigrade. Okay. Yeah. Consider the following statements regarding watt meters. Okay. Yeah. In a pivoted coil direct indicated wattmeter, the fixed coil is wound and two halves right, always the fixed coil is split up into two parts. Always the fixed coil is split up into two parts. Usually sometimes in wattmeters you are going to connect in series, right, for same current range. For higher current ranges, the fixed coil 1 and fixed coil 2, right, fixed coil 2 are connected as parallel. So this statement is correct. Okay. Yeah, suspended coil torsion wattmeters are commonly used as switchboard or portable instrument. But what they are asking, which of the following statements are correct? Particularly in ESE questions, which of the following statements are correct or not correct, they are going to ask. They are asking which of the following statements are correct. Okay, one is absolutely correct, but this two is not correct. Now coming to third statement, in a pivoted coil direct indicated wattmeters, eddy current errors within the region of a magnetic field, the instrument are minimized by the use of non-metallic parts, correct, non-metallic parts with high resistance material. So obviously, so hence we can go for 1 and 3 statements. Option B is the correct answer. Okay. Next, yeah, I think more questions came from dynamometer type wattmeter. What are they given? Tell me. Consider the following statements regarding dynamometer type wattmeter. Again asking which of the following statements are correct. Yeah, because reason correct or not correct they are asking. Dynamometer type wattmeters comparatively consume more power than induction type wattmeters. No. Why? Induction type wattmeters, their construction is complex, right, and it requires more power consumption, but dynamometer type wattmeters less power consumption. So it is a wrong statement. Dynamometer type wattmeters works for both AC and DC systems. These are also called transfer instruments. These are also called transfer instruments. Okay, statement number 2 is correct. Fine. Yeah. Next, what is the third statement? Tell me. Dynamometer type wattmeters provide high degree of accuracy if carefully designed. Yeah, it's correct. So statement number 2 and 3 statements are correct. So hence option C is the correct answer. Okay. Right. Next question. Question number 20. Consider the following statement regarding cathode ray oscilloscope CRO. Which of the following statements are correct? Again they are asking which of the following statements are correct. Okay. Cathode is in cylindrical shape, coated with oxide coating, particularly barium oxides or strontium oxides, emit plenty of electrons at moderate temperature. Yeah, this statement is correct. Fine. Yeah, what is statement number 2? In statement number 2, the typical value of current and voltage required in general in CRO, right, 600 milliamperes, but here they are given 800 milliamperes, right, 600 milliamperes and 6.3 volts. This much voltage is required. This statement is not correct. The control grid is usually metallic cylinder covered at one end, but with a small hole in the correct. This is also correct statement. So available answer is statement number 1 and 3 is correct. Okay. Yeah. The next question. Consider the following statements regarding electrical measurements. What is the accuracy? In general, the accuracy refers to degree of closeness. What they given here? Accuracy of instrument is defined as the conformity with an accepted standard value, right? This statement is true. But again here what they are asking, which of the following statements are correct? Okay, this statement is correct. Next, accuracy of an instrument is influenced by reproducibility. But what is this reproducibility? The word reproducibility is nothing but degree of repeatability. Degree of repeatability. This degree of repeatability or reproducibility related to precision. Hence, I cannot correct. Okay. Next, accuracy of an instrument influenced by dead zone. Yeah, correct. What is mean by dead zone? Dead zone means if you are giving some, if you applied some input, but after applied the input, the instrument will give response. After some amount of input is applied, then only the instrument will give the response. Or in other words, right, dead zone means up to certain amount of input, the instrument cannot give any response. Okay. So, accuracy of instrument definitely influenced. This is also correct. So, again answer statement number 1 and 3 means hence option B. Yeah. Okay. Right. Next questions Naresh sir will cover.
Good evening dear students. Now thank you Mr. Raju sir. A thermometer reads 92.5 degree. Very simple question. This is static correction given in the correction curves is minus 0.75 degree centigrade. The true value, so is given the correction is given and 92.5 is minus 0.75. This value becomes 91.75 or not. Here is a 0.75. You have to subtract, you get a 91.75 degree centigrade. Direct question, the true value is. Next question is consider the following statements regarding the drift. So, instrument is said to be have no drift. If it is a no drift, if it is reproduces same reading at different times for same variation is measured variable as correct. If it's no drift, so this statement is correct. Drift occurs in a resistance thermometers due to the contamination of the metal and the change in its atomic or metallurgical structure के वजह से there is a dead zone will be coming to the picture. A drift, this drift is occurs due to the actual metallurgical structures charge in a change in this atomic, इसके वजह से there is a drift. So this also a correct statement. Second, third is drift may occur in a flow meter due to wear and erosion of the plate nozzle or a meter. This is also a about the drift too is also a correct. So 1, 2, 3 are 3 are correct. This option is D. Now deflection. Now consider the following statements. Here asking about which of the above statements are not correct. The deflection type instruments are more suited for the measurements under the dynamic conditions whose intrinsic response is slower. There are two types of measuring instruments. So the null type and another is deflection type. So null type instruments are not suitable for dynamic. Why? Because it requires again and again is null detection के लिए आप sliding wire को और sliding को आप adjust करना पड़ता है, इसीलिए so deflection type instruments are suitable for the measurements or dynamic conditions. सर नॉर्मली ज़्यादा नहीं होना चाहिए, small variation हो चाहिए, slow response में slow dynamic में ये deflection types are suitable है, ये option is correct है. So deflection type instruments are more accurate than null type है. No, deflection types are not accurate or not sensitive than the null type है. So this is a wrong statement है. And highly sensitive है. No, which one is highly sensitive? Null type is highly sensitive है. So this is now deflection types now 2 and 3 are they not a correct answers. So which are above statements are not correct? 2 and 3 only. C is the option for this question. Next is O. Now consider the following statements regarding the measuring instruments. PMMC पता है, PMC में which is only for the DC or not? So only for DC, not for AC. AC के लिए नहीं है. So this statement is wrong. The calibration of electrodynamometer type instrument is same for both AC and DC. That's why it's called a transfer instrument बोल सकते हैं electrodynamometer. इसलिए this statement is correct. Hardware and thermocouple are used for AC measurements only. Not only AC measurement, DC also is suitable, but is given AC measurements only बोल रहे हैं, but DC के लिए भी applicable है. Option के साथ जाना है. Which of the following above statements are correct बोल रहे हैं. 1, 2 is correct, 3 is correct. 2 is correct, 2 and 3. No, only 2 is correct है, but 3 also correct. Why? Because AC मेजर कर सकते, DC भी मेजर कर सकते, बट ऑप्शन के साथ जाना है तो 2 and 3 आर करेक्ट है. Now consider the following statements regarding Blandless theorem for measuring power in a polyphase systems. So in a network is supplied through n conductors hai. The total power is measured by summing the reading of n wattmeters, so arranged that a current element of a wattmeter is in each line and corresponding voltage element is connected between that line and the common point or not. Suppose 3 wattmeter method hai. 3 wattmeter mein 3 lines are there. It requires 3 wattmeters. This is now current coil is in phase with the line and voltage coil is connected between a line and the neutral point. So this statement is correct. If the common point is located on one of the lines, then the power may be measured by n minus 1 wattmeter. We have studied 2 wattmeter method is suitable for measurement of 3 phase power in a balanced and unbalanced. So totally 3 minus 1. Blandless theorem is said that, so how many maximum number of, means not a minimum number of wattmeters are required to measure the power is n minus 1 or not. So this n minus 1 is also a correct statement. The most common applications of Blandless theorem include the 2 wattmeter method of measurement of power in a 3 phase 3 wire load circuits and 3 wattmeter method of measurement of power in a 3 phase 4 wire load circuits. So this is also a correct statement. So 1, 2, 3 are the statements are correct. So 1, 2 and 3 are the correct options. Option is D. So okay, thank you.
Good evening, dear students. Now let us see the questions from this basic electrical engineering. If you see the questions, the question stand is moderate to difficulty level. Okay, let us see. But the first one is the first. These are the simple statements. Simply use the statements correspond to this Faraday's law. Now correspond to this Faraday's law. Whenever the rate of change of flux is present, that means wherever the d by dt is present, then only EMF is induced. That is about the first statement. Now suppose if you no rate of change of flux are present here, no EMF is induced. Now first statement is the correct. Again, what is the second statement given as a, if you come to this induced voltage is directly proportional to rate of change of flux only. If you increase the rate of change of flux, EMF is increases. Otherwise, if you decrease the rate of change of flux, EMF is decreases. Second statement also correct. Come to the last one. Last one is the ego statements regarding the Lenz's law. It always opposes its cause of existence. That's why it is also correct statement. In the question, what is asking, which of the following statements are the correct? All the given three statements are the correct. Okay. Come to the next one. Next one is inductance. One of the students saying the tough. Don't worry, dear students. आप हमेशा कैसा सोचना बोलते हो? Tough means it is a tough for all the students. देखो जी, second one क्या चाहिए जी आपको? Inductance. What is the inductance basic formula is L equal to n pi by I. As per the given information, check करो. What are the number of turns are the 2000. What are the flux are the 0.6 millivebers. Now what about the current? As per the given data, what is the current value? How much here? 10 amperes. Check करो जी, simplify करने से we get the 0.12. Check करो. What about your answers? बोलो जी, anybody give the answers? Okay. Come to the next one. Now in this one we have to conclude the statements regarding the auto transformer. If you compare this two winding transformer, if you compare the two winding transformer and auto transformer, suppose if two winding transformer, auto transformer have the exactly same rating, same volt ampere rating. Now at that instant the copper material required for the auto transformer is less. Copper material required less means indirectly first we can conclude as a resistance value is less. If resistance less means voltage drop is also less, and size also decreases. That's why we can say resistance is less, reactance also less. If these two are less means we can conclude as a it is having the better regulation. Better regulation means you have to understand as a voltage drop is the less. First statement is correct. What about the auto transformer? In the auto transformer, more flexibility is present. In the auto transformer, as per the requirement, by changing this variable point, we can get the variable output voltage also. That's why second statement is also correct. Come to third statement. Short circuit current is a large. This short circuit current we can conclude with help of the resistance value, reactance value. Just now we concluded when compared to two winding transformer, resistance value, reactance values are the less. But the current formula is we can conclude as a this I is equal to V by Z. If the impedance is the less means indirectly you can say current value is a high. That's why the third statement is also correct. That means again here also all the given three statements are the correct. Now these are the different types of techniques. In case of the transformers, as per the applications, they go for the low rating transformers, medium rating, high rating and very high rating. That's why in some of the cases what they do here, only by using the natural air circulation we can control the heat produced by the transformer winding and core. In some of the cases they use the transformer oil also. In some of the cases they use some external fans also. These are the different techniques used in the transformer to reduce that heat. All the given statements are the correct. Now commutation. If you come to the DC machines, in the DC machines actual induced voltage in the armature conductor is the alternating. But the DC generator, what is the requirement is the output is the unidirectional. To convert alternating to unidirectional, we take the help of the commutator. Whenever you are converting that alternating to unidirectional, that action, commutator action only called as a commutation. If commutation process is not done properly, one of the main problem for this was sparking. To reduce the sparking effect, one of the precautions is what they do here, they try to go for the high resistance carbon brushes. With help of that one we can control the sparking effect. What about next one? In the DC machines, one of the problem for this is the armature reaction. To control this armature reaction they go for the different methods. One of the method for this one is a compensating winding. By using compensating winding we can control the armature reaction. Here also all the given statements are the correct. Now this question is a combination of the basic electrical and as well as the network analysis. What is the first statement given as a 60% lagging? That means sir indirectly you have to understand as per the first statement cos theta. But cos theta equal to how much here? 0.6. 0.6 means if you calculate the angle for this one, we get approximately how much here? 53 degrees. What is statement given as a supply current? That means sir with respect to voltage, you give the statement current is a lagging. lagging how much here? Approximately 53. Yes, this statement is correct only. This statement correct only. Come to second statement. Second statement, you give the 90% leading power factor. 90% leading power factor. Leading power factor means which type of the load? Capacity load. Capacity load correct only. But if you observe carefully, you give a statement the voltage leads the current. It is incorrect. क्यों बोलते हो? Correspond leading बोलते हो with respect to voltage. With respect to voltage, current should be leading. With respect to voltage, current should be leading, not voltage is leading. Not voltage is leading. That's why here second statement is incorrect. Because it is a capacitive load only, but the statement is a current should be leading with respect to voltage. It should be leading with respect to voltage. Come to the last statement. What do you have statement as a correspond third last statement here? Voltage and current both are exactly in phase. Voltage and current both are exactly in phase. If both are exactly in phase, what is the angle equal to 0? Angle 0 means what is cos 0? Cos 0 equal to 1. For power factor, one of the formula is P by S. That means active power by the apparent power. If cos theta equal to 1, we can conclude as a that apparent power and active power both are exactly equal. For active power, one of the name for this is the true power. That's why here in this example here, first statement and third statements are the correct. The first statement, third statements are correct. Come to the next one. In this example, we have to imagine as a, just imagine as a, it is one charger. This charger is connected for charging of the battery, for charging of the battery. This battery itself has certain amount of the internal resistance. That battery itself has certain amount of the internal resistance. That battery itself has certain amount of the internal resistance. In this example, as per the given data, during charging, देखो जी, what is the output voltage? How much we are getting has a 11.5. Output voltage कितना आ रहा है जी? 11.5 volts आ रहा है इधर. What is the current कितना flow आ रहा है इधर? Now corresponds during charging current of this is 37.5. In the data itself, resistance value is given. Resistance value is how much here? 0.00. 0.008. Now for this particular example, what is asking the, what is the voltage correspond to the charger? In this particular example, what is the voltage correspond to the charger? Can I select this here? Voltage of this entire combination, this voltage both are exactly equal. Simply by writing the KVL equation, can you find out the voltage? Current value is known, resistance known, we can find out the respective values, can find respective values here. If you simplify this one, you get answer for this one 11.8. Wherever the current is entering, this is a positive and it is a negative. If you add these two here, this voltage is obtained, this voltage is obtained. Okay. Okay, dear students.
Hello everyone, welcome to the video solution of ESE 2026 preliminary examinations, branch electronics and telecommunication, subject EMT. The solution that I am going to take is from the set C, right? So let us look at the first question. Question number 91 in the set C, a low loss transmission line of 50 ohm characteristic impedance. So Z0 is given as 50 ohms, correct? And connected to a load, so ZL is given as 100 ohm. So they are asking what is the voltage reflection coefficient gamma. So gamma is nothing but your ZL minus Z0 upon ZL plus Z0, right? And what is the standing wave ratio? S will become 1 plus mod gamma upon 1 minus mod gamma, right? So when you solve it, you will get the answer as 91. Option C will be the correct answer. Next, question number 92. Dissipationless. Dissipation means there will be no power dissipation. Dissipation dissipationless means there is no dissipation of power. That means it is a lossless only. Whose characteristic impedance is 200 ohms, right? So characteristic impedance Z0 is given as 200 ohm, fine, and load impedance ZL, it is given as 100 plus J 100 ohms, right? Okay. The frequency of operation is mentioned as 300 megahertz. Length of the line is given as 25 centimeter. Then they are asking what is the input impedance. We know that first of all we have to calculate beta L, right? So length is given, beta is known. Known in the sense beta can be found as this is a 2 pi by lambda into L is your length. So since it is a lossless, so I can convert this 2 pi is equal lambda can be written as C upon F into L. So this will give you in the radian. This radian has to be converted into degree, right? So radian, this has to be converted into degree, and then I can apply the formula Z in is equal to Z0 ZL plus JZ0 tan beta L divided by Z0 plus JZL tan beta L. Just apply this formula and then you will get one answer, right? So when you solve it, you will get 92, option B, 282.80 ohms. So this will be the magnitude of the input impedance, correct? So option B is the correct answer. 93. Consider the following statements regarding waveguides. The phase velocity is defined as the velocity of propagation of equiphase surface along the guide, right? Okay. So here 93. So that option A is correct. Group velocity is defined as the velocity with which the group of the waves as a whole travels. That is also correct. Group velocity is always more than the free space velocity. That means it is saying that Vg is greater than C. That is wrong. So answer is 1 and 2. So option A is correct. So 93, option A. Question number 94. Consider the following statement regarding modes of propagation of electromagnetic waves. The impedance value for TM, MN modes is always less than 376.8. That means this is same as 377 ohms. That is correct, because we know that eta TM, this is equal to eta TM root under 1 minus FC upon F whole square, right? And this value is always less than 1. So obviously in that case eta TM will be less than eta TM, and eta TM is how much? Around 377 ohms. So option A is correct, always less than, correct. Okay. For the TMN mode in a rectangular waveguide, M and N denote the number of half sinusoidal in the electric field distribution along the long and the short. So that is also correct, fine. Okay. TM0 mode cannot exist in rectangle. That is also correct. So they are asking which statements are correct. So all the 3 statements are correct. So answer will be 94D, 1, 2 and 3. '95. Consider the following statements regarding the cavity resonators, correct? At high frequency, the electromagnetic wave cavity resonator replaces the lumped parameter RC resonate circuit. That is wrong actually. So this is wrong. A thin coating of silver is more than sufficient for the inner walls of the cavity to compensate the losses due to the skin effect. That is correct. The Q factor of the cavity is of the order of 10,000 and above. Which of the statement is correct? This is also correct. So 2 and 3 are correct. 2 and 3 only. Option C. So question number 95, option is C. Next, question number 113. Consider the following statement regarding electromagnetic fields and waves. An incompressible fluid of non-zero value of divergence at a point X represents the rate at which the fluid is being gained or removed at point X. That is correct. Twice the velocity at any instant of time equals the curl of the angular velocity. So this is wrong. V equal to R omega generally. A field which is not irrotational is sometimes called as vortex field. That is also correct. So 1 and 3 should be the answer. So 113 answer should be B. '114. a vector A in spherical coordinate system is defined by, this is the given coordinate system. In the spherical coordinate system they are asking, right? Then the curl of A. So obviously you have to apply the formula del cross A. They are asking what is the del cross A, which is should be the function of AR only, right? So that means it is a function of R. So when you solve it, del cross A formula, if you apply and you go only for up to R, so you are going to get option C to be the correct answer. Hundred 115. Consider the following statement regarding Maxwell's equation. The total electric flux density or total electric flux displacement through the surface enclosing volume is equal to the total charge within the volume. That is correct. This is simple Gauss law, right? So it is saying D dot ds equal to charge enclosed. Net electric flux emerging through any surface, any closed surface, is 0. That means net electric flux, that means D dot ds is equal to 0. No, that is wrong. So 2 is wrong. The magnetomotive force around a closed path is equal to the time derivative of the magnetic flux density or magnetic displacement through any surface bounded by any surface, right? So by the surface, basically we know that H dot dl, it is equal to J plus del D upon del T, right? Dot ds, correct? So magnetomotive force around a closed path is equal to the time derivative of the magnetic flux. No, it is time derivative of basically electric flux. So this is also wrong. So actually the question is saying which statement is not correct. Which statement is not correct? So which is not correct? So not correct is 2 and 3. So 2 and 3, option C will be the correct answer. 116. Consider the following statement regarding Maxwell's equation. When the displacement current is very much greater than the conduction current. So displacement current is very much greater than the conduction current, right? So JD means this is equal to mod of J omega epsilon into E, very greater than sigma into E, right? So therefore I can say that omega epsilon is very greater than sigma. So that means sigma upon omega epsilon, right, should be very less than 1. So it is a dielectric, good dielectric. So option 1 is correct. For good conductor, sigma and epsilon are independent of frequency, but for most of the dielectric, the constant sigma and epsilon are function of frequency. Under these circumstances, the ratio of sigma upon omega epsilon is called as the frequency factor. That is correct. The term sigma upon epsilon is also sometimes. So that means you can see, you can link from here also. Also, that means sigma upon epsilon is also sometimes referred as loss tangent. We know that sigma upon omega epsilon is loss tangent. Is also, that means it is also, basically you can go back, this is also correct. So that means all the 3 options are correct, 1, 2, 3. So option D will be the correct answer. 117. Consider the following statement regarding electromagnetism. Intrinsic impedance is function of frequency and is less than that for a perfect dielectric, right? So basically we know that eta is equal to root under j omega mu upon sigma plus j omega epsilon, is it? So it is saying that for perfect dielectric sigma will become 0, right? So that means if sigma becoming 0, so eta will give you the maximum value, because if the sigma increases, eta value will start to decrease, right? So here they are saying that intrinsic impedance is a function of frequency, it is less than that of the of a perfect dielectric. So that means here it is correct, because if sigma is coming in the picture, denominator will increase, the overall value will decrease, right? So it will be less than. So statement 1 is correct. An increase in the frequency or loss in the dielectric results in the lowering of intrinsic resistance. So you have to calculate this, because from here in the solution, detailed solution, can see mod eta, it is equal to root under mu upon epsilon upon 1 plus sigma upon omega epsilon whole square to the power 1 by 4, right? And theta eta is basically your half of tan inverse sigma upon omega epsilon, right? So here it is saying that increase in the frequency or loss in the dielectric. So that means loss in the dielectric means sigma upon omega epsilon will increase. So if sigma upon omega epsilon will increase, it means that tan inverse higher value, right? Increase in the frequency or loss, right? So basically increase in the frequency, correct? So increase in the frequency. So if you increase the frequency, so overall sigma upon omega epsilon will decrease. So decrease means theta eta will tending to 0, right? In that case theta eta will tend to 0 because increase in the frequency, correct? So if you increase in the frequency, then what will happen? Or so if you increase the frequency, this whole value will start to decrease, and if this whole value start to decrease, so that means tan inverse value, if it is decreasing, that means the whole theta eta is going to tending to 0. Similarly here also, if you increase the frequency, the overall value will go on decreasing, right? So it is saying that it is lowering the, so if it is decreasing, right, so this value will decrease, correct? So sigma upon omega epsilon value is going to decrease. So what will happen? Denominator will tending towards 1, so the value is going to increase, right? So question number 117, which is not correct, so 2 is wrong. In high frequency case, the skin depth represents the depth at which the electric intensity is 0.707. No, so if the high frequency is high, we know that skin depth is inversely proportional to root of f. So if you increase, skin depth will decrease. That means for the high frequency component, delta will tend to 0. So this is wrong. So they are asking which are not correct. So 117, 2 and 3, 2 and 3 only. So 117 answer will be C. The depth of penetration may be defined as the depth at which the wave is around 37%. So it is direct question, 37%. 118, option B. 119. The plane z equal to 0 and z equal to 4 carries a current, this one, the magnetic field. So there is a formula for the sheet, this is half of k cross an, right? So if you look at the solution, you will come to know. So it is your basically 0. Now what is k? K is basically, let me give you a small analysis, brief analysis. So this is x axis, y axis and z axis. So this is z is equal to 4 and this is z is equal to 0, correct? So this is the basically sheet current or surface current and an. So the point is your 0, minus 3, 10. So this is your an. So in this case, an will be your az, right? And for this, an will be again az, correct? K vector is given, you have to just apply the formula, you will get the answer as A. Consider the following statements regarding transmission lines. In a single stub matching, the combination of stub and line represent a conductance which is equal to twice of the characteristic conductance of the line, right? Actually it is not twice, right? Actually it is not a twice, it is not twice actually. So it is basically equal to, it is basically equal to, it is not twice, right? So what they are not correct. So basically one is not correct. Single stub matching is useful for all frequencies. No, it is not for the all frequencies. 2 is wrong. Single stub matching system is a narrow band frequency, that is correct. So they are asking which are not correct. So 1 and 2 are not correct. 1 and 2, option A should be the answer. 120, option A, right? So that is the answer.